Hey, this is Andrew Brown, your Cloud Instructor at Exam Pro, bringing you another complete study course, and this time it's the Microsoft Azure Developer Associate, also known as the AZ-204, made available to you on Free Codecamp. This course is designed to help you pass and achieve Microsoft-issued certification, and the way we're going to do that is by doing lecture content, follow-alongs, a practice exam, and have cheat sheets for the day of the exam, so you can prove on your resume, your LinkedIn, you have that Azure knowledge. You can go get that cloud job or get that promotion. To tell you a bit about me, I was previously the CTO of multiple edtech companies, 15 years industry experience, 5 years specializing in cloud. I'm an AWS community hero, and I've published many free courses just like this one. I love Star Trek and coconut water. And I just want to take a moment here to thank viewers like you, because it's you that make these courses possible. And the best way to support more courses just like this one is to purchase the additional study materials at AZ-204. So you can get access to study notes, flashcards, Quizlets, downloadable lecture slides, downloadable cheat sheets, practice exams, ask questions, get learning support. But if you sign up right now for free, you'll get a practice exam and cheat sheet. There's no credit card required. The free stuff does not have a trial limit, so you do not have to worry about it vanishing. It's not a demo. If there are updates to this course, they'll be in the YouTube descriptions on Free Codecamp. So watch out if there are corrections, additions, modifications to make sure you're using the latest version of this course. And if you want to keep up to date on upcoming courses, the best way to find that is on Twitter. I'm at Andrew Brown on Twitter. And if you do pass, I love to hear your success story or what you'd like to see next. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are at the start of our journey asking the most important question first, which is, what is the Azure Developer Associate? So it's a Microsoft certification about the Azure platform, focused on multiple ways to deploy web apps to Azure, a deep dive into Azure functions, and I mean seriously deep, a broad look into application integration services, which Azure has a lot of, to the point where they have ones that cover the same purpose, and lots of hands-on with Azure CLI, SDKs, or programmatic interactions with Azure services, so anything to do with the Azure API. The course code for the Azure developer is the AZ-204, not to be confused with the 104, but it is very complementary to the other course, which we'll talk about when we talk about the roadmap. And I do want to point out that Microsoft Azure is a very code and script-driven platform compared to AWS and GCP. So it's better having developer knowledge, and I actually consider it a must when we're working with Microsoft, and I'll explain why here in a bit. So who's the certification for? Well, consider the 204 if you are a web app developer looking to pick up cloud skills or transition to a cloud developer role. You are a cloud developer or cloud engineer who needs to integrate Azure services into your app or deploy your app to Azure, or you need to learn a lot about Azure functions to build service workloads. But as a note, I kind of feel that this is an essential certification at the associate level. And so looking at a roadmap, I always suggest people to start with the AZ-900, which is the fundamentals, because it's going to really help you get not just introduced to Azure, but also the test-taking experience, because it is a much difficult and different experience than the other two providers. And generally from that, we usually recommend to go with the administrator, the 104, because that is a broad amount of services. And that is the most common use case why people are on Microsoft Azure, because they're usually IT dev shops. But as a complementary, usually after that, I would recommend to go to the developer, the AZ-204, because the nature of Azure is that a lot of the UI is script driven. So when you are in the portal, you have to touch script more often than not, or you might run into features that simply do not exist in the portal. So you have to use scripting. So really, to be a proficient person working on Azure, you need developer programming experience. And so I always pair these two together. Now, where you want to go after that is up to you. A lot of people like to go to the solutions architect or the DevOps engineer expert. There's a bunch of other associates, and I consider these kind of like mid-level specialties where you can do those. There's, of course, more certifications than we're looking at that is actually here. But, these are the most general ones here. So, hopefully that gives you an idea that you should probably take the developer after your associate, and then after that, you can go wherever you want. In terms of difficulty, the Azure Developer Associate is, I would say, 2 times harder than the AWS Developer Associate and 3 times more difficult than the GCP Associate. And I'm talking about the exams, not necessarily the application of being a developer in the platform, but just the fact that the way Azure makes their exams is they really want to test for practical knowledge. So it's not about conceptual or strategic information, not to say that there isn't those kind of questions on the exam, but it's a huge focus on, do you know how to actually set things up? And do you know the nuances of them? So you're going to see a lot more labs than normal in my courses for this particular study course. How long does it take to pass? Well, it depends on you, but to give you a general idea, if you're a beginner, so let's say you have the AZ900, but not much hands-on experience, you've never written code or a tech role, then you're looking at 50 hours. Even if you've taken the AZ104, it's still going to take this long because it's a different beast than the 104. If you're experienced, so you already have practical knowledge working on Azure, you've deployed apps to Azure, you have a strong background in programming, you're looking at 20 hours. And so I like to set a goal of somewhere in between, so 30 hours, average study time. So for lectures and lab, that's going to take up 50% of your time. So, when we're looking at, it's probably more labs and lecture. And then the other part of it is 50% practice exam. So I recommend you study 1 to 2 hours for 20 days and really do spread that out, because if you do too much of it together, you have a good chance of forgetting information. So, make sure you spread that out and make sure that it becomes part of your long-term memory. So where do you take the exam? Well, you can do it in person at a test center or online from the convenience of your own home. So Microsoft delivers exams via 2 different providers, PSI Online, Pearson VUE, and those are online proctor exam systems. Both of these providers have their own test center networks. So whether you want the online experience or in person, it's just going to be up to you. I strongly recommend, if you can, to go in person. It's less stressful if you have the opportunity. If you can't, you have to do it at home. It's up to you which one you want to choose. They're more or less the same. I like Pearson VUE, but some people like PSI, so it just depends. After you take a couple, you'll decide which one you like. And if you're wondering what the word proctored means, it means there's a supervisor. Somebody is monitoring you as you take the exam to make sure you're not cheating. That's the whole idea behind it, to make sure these are legitimate scores. So what does it take to pass exam? Well, you're going to have to watch video lecture, memorize key information. You have to do hands-on labs and follow along within your own account. I would recommend paid exams to simulate the real exam. And I'm going to help you out by giving you your first exam for free. No credit card required. Just sign up on Exam Pro, and you can go get access to that and other free additional content that I strongly recommend that you do. For the content outline, we got 5 domains. Each domain has its own weighting that determines how many questions in a domain will show up. And Azure is interesting because they do a range of questions. So it's not a guaranteed of a certain amount of questions on exam. It's going to be between ranges. So the first is develop Azure Compute Solutions, develop Azure Storage, implement Azure Security, monitor, troubleshoot, and optimize Azure Solutions, connect and consume to Azure services and third-party services. In terms of the grading, you got to get about 70% to pass. And they use scaled scoring, so it's not always exactly on the dot, but for the most part, if you get 70%, you should pass. In terms of amount of questions, there's between 40 to 60. You probably will see 55 questions, so you can afford to get about 12 to 18 wrong. Some questions are worth more than 1 point. There's no penalty for wrong questions. Some questions cannot be skipped. And for the formatted question, you got multiple choice, multiple answer, drag and drop, hot area, case studies, all sorts of kinds of questions that you'll encounter. Much more difficult than the AZ900 for sure. In terms of the duration, you get 3 hours, so that's about 1 minute per question, but of course, different question formats are going to be different. You have 180 minutes for the exam time. Your seat time is 210, so you have about 30 minutes in terms of the whole time that you should schedule. So even if you have 180 minutes, you have to consider the entire time to get logged in and all that other stuff. So time to review instructions, read and accept the NDA, complete the exam, provide feedback at the end. And I'm telling you, if you're taking this online, show up early, because so often you're fiddling around with your license to try to get it to scan properly, and then they don't like it, so you have to scan it twice. So, if you can, show up an hour early and make sure you block that time. This exam is valid for, I believe, 2 years before recertification. So, there you go. Hey, this is Andrew Brown from Exam Pro, and before we dive into Azure Functions, we need to understand what is serverless. So serverless architecture generally describes fully managed cloud services, and I say generally because that definition of serverless can be highly contested about what can be serverless and what cannot be serverless. So it's not a Boolean answer of yes or no, but some services are more serverless than others to a degree. And so, the way to help you understand serverless is the way I define it is I look at the following characteristics. One thing for a cloud service to be serverless is that it should be highly elastic and scalable, highly available, highly durable, and secure by default. Another thing is that it abstracts away the underlying infrastructure and are built based on the execution of your business task. So you're not really worried about how many CPUs and things like that. Maybe they are abstracted into like virtual CPUs or away from what the original hardware software is using. The idea is that it's a simpler value. Then the idea is that serverless can scale to zero, meaning that when it's not in use, you're not paying for anything. And the most important thing is you're paying for value, so you do not pay for idle servers. And just to kind of reinforce that idea that it's a degree, my friend Daniel, who's really big into serverless, loves to describe it as like the energy rating system. So the idea is that when you go to buy an appliance, such as a washer or dryer, they'll tell you how energy efficient it is, and that's kind of the idea behind serverless services. And we're going to be talking about function as a service, but function as a service does not necessarily guarantee that it's a serverless service, but we'll talk about that in the next slide, okay? All right, let's talk about function as a service, also known as FAST. So here's kind of a diagram that I like to use to visualize it, but we'll get to it in a moment here. So what is function as a service? It allows developers to focus on just writing pieces of codes, also known as functions, and it has event-driven integration trigger functions based on event data or to emit event data. So it's not just a matter of having a piece of function or code that you write in a box, but the fact that it has to be event-driven. Generally, multiple functions are orchestrated together to create a serverless application, sometimes also known as microservices. Functions generally only run when needed, and so function as a service is not serverless on its own. So fast function as a service is only serverless if it's fully managed and it scales to zero. Just to take a closer look at this graphic here. So the idea is that if we're talking about the underlying infrastructure, it's of course running on some kind of physical server. And from there, you'll have a host operating system. And then it could be a hypervisor. And then from there, you could have a virtual machine running a container runtime like the Docker daemon. Or, it could be, there are some OSs that are optimized to run a container runtime without a hypervisor, but the important part is the idea is that you're just deploying these little pieces of functions, and they generally will go into a container. So you might have a container runtime that is specifically configured for Ruby, or it might be configured for Java or Python or .NET. And then the idea is that you're dropping that code, and that code's getting scheduled into that container. But hopefully that gives you kind of the general idea of what function as a service is. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Azure Functions. And this is a function as a service, FAS, offering that allows developers to focus on writing code and not worry about maintaining the underlying computing infrastructure. And so here is our visualization, so we can kind of break down the anatomy of how Azure Functions work. So the first thing you'll need is a function app, and this defines the underlying compute for a collection of functions. So a function app defines the hosting, runtime, and global configurations. Then you have the functions themselves, and these represent code along with application runtime configurations. So the idea is you can say, I want this to be a Python function, a .NET function, etc., etc. There's always going to be a trigger. So a trigger is the chosen event data that will cause the function to execute, and you can only have one trigger. You have input bindings. These are one or more multiple data sources that will be passed to the function when a trigger occurs. So the idea is you can pull in data from a variety of different Azure services at the time of trigger, which is quite nice. And then you have the output bindings. These are one or more data syncs that will receive outputted data from the function on successful execution. They say syncs, you could say consumers if you like. And also Azure Functions, at least as of today, has 4 different versions. You really do want to just use the latest version. There could be a version 5 out by now, I don't know. But just be aware that you're always using the latest version. But in practicality, you probably won't be able to tell the difference between the versions. But just make sure you're using the latest, okay? All right, let's take a look at storage considerations for Azure Functions, because every function app requires a storage account to operate. And if that account is deleted, your functions are just not going to work. So kind of a small visualization of your function app linked to a storage account. So Azure Functions uses the following storage types in the storage account. It's going to vary based on use case. So for blob storage, it maintains binding state and function keys. For Azure Files, file share used to store and run function app code in a consumption plan, premium plan. Azure Files is set up by default, but you can create an app without Azure Files under certain conditions. For queue storage, this is used by task hubs in durable functions. We have a whole section on durable functions. And then for table storage, used by task hubs in durable functions as well. So there you go. Okay, let's take a look here at the anatomy of a single Azure function. So here is a screenshot of Visual Studio Code, because this is where you're going to be writing your functions. You can write them somewhere else. I sure don't know where, but they have really strong integrations with Visual Studio Code. But the idea here is that we have a Visual Studio Code plugin installed that allows us to manage our remote functions, and we have local projects. But let's take a look at some of the files that are in here so we can understand what kind of files matter to our functions. The first is functions.json. This is configuration of a single function defining bindings, and we talk a lot about bindings in the Azure Functions section of this course. There's the code itself, and in this case, it's a JavaScript file. We have the func ignore. That's just like a get ignore file, but it's to ignore files, like files to be not packaged, right? So like when it actually deploys the function, you don't want those files included, but you might use them in local development. We have host.json. This is global configuration of all functions at the function app level. Then there's the local project itself. This is just where the function is stored locally, and a lot of times you're moving that code to the remote storage on Azure. And if we were just to open that up, you can kind of see the same files being mirrored. So we have the name of the folder, so this is host.json, function.json, index, etc., local settings, JSON, package, JSON, things like that. So I'll just kind of erase a little bit of this out of here, but you get the idea, and it will make a lot more sense when we start making functions, which we absolutely do in this course, critical for the AZ204. So, but we'll do that soon. All right, let's take a look at authorization levels. This determines what key, if any, needs to be present when making a request when a function is getting invoked. And the authorization levels can be one of the following. We have anonymous, function, and admin. So anonymous means that anybody can invoke the function. So if it's an HTTPS request, in order to trigger it, anybody can trigger it. For function, you'll need a specified API key. This is the default value when you're creating your functions, generally recommended as the means to use. Or you can have it so that it has to use a main key to be required. Yes, it's called master key. I'm just going to use the word main key. And for integration, if you're trying to figure out how to change the authorization levels after you've deployed a function, you're just going to click on your HTTPS trigger, and from there you can switch the authorization level. Now, that's not always the case. There's some cases where you're not able to change it via the portal, and that just has to do with, you know, the type of runtime you're running, whether it's a custom runtime. But yeah, that's where you're going to do it there, and you can change it after the fact, after creation. Okay. Let's talk about how we would debug our Azure function. Well, you have this ability to turn on streaming logs, and this allows you to see near real-time logging when errors occur. And it's not as just simple as that, because there are two options for streaming a file log. The first is built-in logging stream. And so the idea is that you have the app service platform lets you view a stream of your application log files. And then there's live metric stream. So when your function app is connected to application insights, you can view log data and other metrics in near real time in the Azure portal using live metric stream. And log streams can be viewed both in the portal and in most cases, the local developer environments, such as Visual Studio Code. Now, when I was doing this, I was trying to turn it on and I did not get any logs in near real time, but I think the reason why was because the hosting that I had it backed on wasn't on app service platform. So I think it really does matter where you host it. And so, you know, maybe we'll explore that in the follow along to see if we can see near real time logs. Yeah, there you go. All All right, let's take a look at the key concepts for Azure Functions. These are not exactly my words, but I will provide exceptions here as we describe this stuff. But the idea here is that we want to get broader knowledge about Azure Functions. So Azure Functions are lightweight and can be serverless. And they can be, and this is all going to be dependent on how you host them. And we'll talk about that in a moment. Azure Functions are easier to write and deploy, easier to write and deploy than full web applications. That can be true. The idea, though, is that you might have to do less coding in some regards, but then you might have to do more in other places like application integration. So I would say that it shifts the responsibilities of what you have to work on, but it is better. I think Azure Functions are fast to execute because there is no large application, startup time, initialization, or other events fired before the code is executed. Now, true that large applications, there are those downsides to them, but the trade-off here is that if you're using serverless functions, then you will be dealing with cold starts. And so cold starts just means that when you have a function that hasn't been used in a while, that's going to have to boot up an environment. So there is that trade-off. Now, in many cases, you can pre-warm or have continuously running compute. But if you do that, then you're not necessarily leveraging serverless like to be able to scale to 0. But you do get trade-offs. Azure Functions execution is triggered when an event is fired. That is true. Azure Functions do not need any infrastructure and have 0 maintenance. Well, they do have infrastructure. It's just that you don't generally have to worry about the infrastructure. In terms of Azure's implementation of functions, you do have to think a little bit more in general about the infrastructure underneath as opposed to Google Cloud or AWS, but at least you have a lot of options on Azure, and it has 0 maintenance. Well, the infrastructure, that's true, but your code itself, if you're using Python 2 and Microsoft says, hey, we're going to expire or deprecate the Python 2 runtime, you have to use Python 3, well, then you're going to have to upgrade that stuff. So that is your maintenance. So there is maintenance with code, but that's no different than any other provider. Azure Functions can be built, tested, deployed in the Azure portal using a browser, only if you're using Windows. So if you are hosting on Linux, there are definitely lots of limitations in the Azure portal. If you're using Windows, then there's no problem. In most cases, you should just use Windows because you're not going to be able to tell the difference in most cases. But if you want to take the full advantage of being able to work in the portal, absolutely use Windows. Azure Functions are easy to upgrade and doesn't affect other parts of the website. Again, this is subjective based on the code that you have to upgrade, right? So, or functionality that they change. So, generally it's true. It can be easier in isolate to update parts of your application because they're all little functions, but there are exceptions to that. Azure Functions use industry standard protocols, probably HTTPS here, and can communicate with other APIs, databases, and libraries. That's true. You only pay while your functions are running. That is true if you use the serverless model. If you're continuously running virtual machines behind the scenes, then you are going to be paying all the time. Azure Functions automatically scale to meet the demand of traffic. That is true. Underneath, Azure will provision more serverless containers. That is true. Azure Functions scale to 0 cost. Again, depend on your hosting. Azure Function has built-in monitoring via Azure Monitor, which it absolutely does, and it can integrate or has built-in CI/CD via Azure DevOps, which is very nice. Azure Functions are event-driven and will be triggered based on event data and emit event data. Absolutely, and if they didn't, then it wouldn't be function as a service. But there you go. All right, let's take a look here at use cases, both business and technical, for Azure Functions. So for business use cases, you could use them for scheduled tasks, reminders and notifications, lightweight web APIs, sending background emails, running background backup tasks, doing backend calculations. There are technical use cases such as sending emails, starting a backup, ordering processing, task scheduling, database cleanup, send notifications, messages, IoT data processing. So Azure Functions are best suited for smaller apps that have events that can work independently of other websites. Originally, I had some text in here that said like Azure Functions were not suited for large applications, but more of these menial jobs around a larger application, which is not true. You can build a whole application out of functions. Now, whether that's easy to do with Azure Functions is another story because it has to do with cold starts and things like that. But I definitely think you can, but this is just kind of give you creative ideas of how you can use Azure Functions outside of the normal use case of just building a web application. So there you go. All right, let's take a look at VS Code extension, because this is going to be the primary way that you are going to be working with Azure Functions. So in order to productively work with Azure Functions, you'll need the Visual Studio Code Azure Functions extension. And so what you'll do there is install that. Once it's installed and you have an Azure icon in your activity bar with the sidebar drawer, you can look for functions. I'm going to get my pen tool out here. So the idea is you install this, and then now you have at the top here the functions tab, so you can manage Azure Functions. It's possible to use Azure Portal to create and update Windows hosted Azure Functions, but in practice it's not an easy experience, and with Linux it's impossible. This is a very kind of different experience compared to something like AWS or Google Cloud, where you can do basically everything in the cloud, but with Azure Functions you really rely on Visual Studio Code. You can use Visual Studio for .NET and C# app functions. I've never done it myself, but it is an option out there, so there you go. Well, let's talk about runtime. So what is an application runtime? An application runtime is a compute environment configured with the necessary software and system configuration to run a specific type of application code. So here, if we were to create an Azure function, we have some options, and you can see runtime stack. So Azure provides multiple applications and runtimes for popular programming languages. Just going to highlight that out there because I don't see my my arrow, but it has things for .NET, so that's C#, Java, Node.js, that's both JavaScript, TypeScript, PowerShell Core, Python. There's my nice arrow there. Unfortunately does not have Ruby at the time of recording this. I really would like them to have it, but if you want something that's not there, what you can do is implement your own custom handler. I believe they have an example either for Rust or Go in the documentation, or let's say you want to do Ruby. That is something that's on the tool for exam, but in practice, it's really hard to get a working custom handler. And I say that by, I tried to make a Ruby one, it didn't work. I tried their tutorial, it didn't work. I reached out to the person that wrote the tutorial, they couldn't get it to work. I went to support, they couldn't get it to work. So in theory, custom handler sounds great if you can figure it out. So, you know, if there isn't a custom handler, follow along, you'll know why. Yeah, that is an option on the table. The runtimes provided by Microsoft are just Docker containers. You can see them on the Docker Hub. And, you know, a lot of times, you know, containers and functions are strongly related because they're generally almost always running on containers, okay? All right, let's take a look at Windows versus Linux hosting. So when you create an Azure Function app, you can choose either Windows or Linux as your host. And this actually makes a big difference based on the capabilities that are available to you. And we're talking about things where there could be performance differences, functionality limitations, feature differences. But generally, you know, when we're using Microsoft, it's always good to attempt to use Windows when possible because their whole ecosystem is built around Windows and not so much Linux. One example here is that if you are using a Linux hosting for Azure Function apps, you cannot edit the function after it's been deployed. And that is a very major inconvenience. So just consider that when deploying functions, I usually can't tell much the difference between Linux and Windows. So I'll just choose Windows so I get that additional functionality. If you need to determine the exact OS that is being used, what you can do is go to Docker Hub repository, because again, all these images or runtimes are stored on Docker Hub. And there we can see the Windows images and the Linux images. And notice for Linux, there is a lot more variation, where Windows is just the Nano Server 1809. So that's the Windows Server 1809. Whereas Linux, there's a little bit more options, and mostly Debian, but you do have one down here that's Ubuntu, but there you go. All right, let's take a look at templates for Azure Functions. So Azure provides function templates to get you started with common functionality scenarios. This is going to happen when you first create your function. Now, you don't have to use one, but definitely this is the route that you should want to go, especially if you're choosing HTTP triggered, which is very common. So to choose a template, you're going to be doing that in Visual Studio Code, so you don't do it in the portal. But let's kind of walk through the templates we have available. So we have HTTP, so triggered by an HTTP request, and returns an HTTP request. You have a timer, so triggered based on a schedule. Blob storage, triggered when files are updated in a blob storage container. Cosmos DB, triggered when processing a new modified Cosmos DB document. Queue storage, triggered by Azure Storage Queue messages. Event grid, so triggered by event from event grid. So many Azure services can be triggered as a function through event grid, because as we cover event grid in this course, a lot of sources can be ingested into event grid. Event grid is serverless event bus integrated with Azure Service, as we do cover at other parts in our course. Event hub, so triggered by an event hub event. So this is for streaming. Service bus queue, so triggered by a bus queue. This is messaging. Service bus topic, so triggered by an event from a bus topic. So this is pub sub model. Then you have SendGrid, so triggered by an email event in a third-party service. SendGrid, if you've ever heard of SendGrid, it's just for sending out emails. And so there's a lot there. Does it set up the bindings for you? Probably. I never really noticed or checked, but I would think that if you were to set one up for blob storage, you would get the binding set up for you in your function JSON. But we will look actually next at function JSON configuration, because that is what is next in the course. So for every single function, there is a function configuration file called function JSON. And so there's the structure there, and it defines the function's triggers, bindings, and other configuration settings. When you choose a template, you're going to get some default stuff there. Let's talk about three main things under bindings. So you have the type of binding, which is just the name of the binding, which will affect the other attributes that are underneath. Often you'll have a direction like in and out. And then there's the name, and the name is going to vary. So for C#, it's an argument name. For JavaScript, it's the key value list, but it's what is used to bound data in the function. And we will definitely cover a lot about bindings, because bindings is super important. But just so you know, function configuration file, again, is for trigger bindings and other configuration settings. Another file that you will find in your function is a hosts.json, and this is for configuring global configuration options for all functions within the function app. Here is an example one. So it has an extension for HTTP. You can see it has a route prefix, things like that. It's setting a custom header. And there is a lot of stuff you can configure here for options. So we can do aggregators, application insights, blob, console, Cosmos DB, extensions, and then, HTTP, queues, retry, SendGrid, a whole host of things. And, not super important for the exam, but definitely in practice, you will be going to this file and configuring things need be. But there you go. Let's take a look at plan services for Azure Functions, and we have three to choose from: consumption, function premium, and app service plan. Very different, very interesting options for you to decide where you want your compute to run and how your compute to run for functions. You do not see AWS or Google Cloud doing that, but the flexibility here is very interesting. So the first is consumption plan, and this would be considered serverless. And because it's serverless, it can scale to 0. And because it can scale to 0, that means that generally we will have cold starts. So you only pay for the time your code or application is running. Billing is based on the number of executions and the duration of each execution and the amount of memory used. Just pay while you have functions running and scale it automatically, even through long loading times. Then you have premium plan. These are functions premium. This is where we have pre-warmed compute underneath. So the user has designated a set of pre-warmed cases, which are already online and ready to react instantly. Azure provides any additional computing services that are required when your function is running. You pay for the constantly pre-warmed instances, including any additional instances needed to scale the Azure app in and out. Azure Functions host instances are added and removed based on the number of incoming events. So, the idea there is that you're not waiting for the container runtime to spin up. It's already running, but it's not going to scale to 0 And I mean, you can still say that it's serverless in some regard. I would consider that now being a fully managed service, but not necessarily serverless. But that's debatable. The last here we have dedicated plan. This is with app service plan, and this is where we're doing VM sharing. And this one is extremely unique. You do not see this in any other cloud provider, but this is where when you use app service for other apps, your functions will run on the same plan, virtual machine, at no extra cost. You may scale it out manually by adding more virtual machine instances for an app service plan. You may also have auto scale enabled, optional when you have existing underutilized virtual machines, which also operate other instances of the app service. So I think what happened was people were using app service, right? Platform as a service. And they just had they weren't utilizing all of the virtual machine compute. And so a customer must have said, hey, can I just take my functions and utilize the unutilized compute on my plan? And that's Azure's like, sure. And they made that a thing. So it's just like an interesting way to save money, but it is one of those things where it is a little bit hard to understand because it's not as isolated or modular in terms of functionality where we see other cloud service providers, but those are your 3 plans. So there you go. All right, let's take a look at triggers and bindings for Azure Functions. We talked about them before, but let's give them a little bit more attention. So triggers and bindings let you avoid hard coding access to other services and abstracting away boilerplate code, keeping your functions lean. Because the idea is that you won't have to add that code into your functions. So here is our graphic, which represents a function. We have input bindings, output bindings. We have a trigger there. So what is a trigger? A trigger is a specific type of event which causes the function to run. It defines how a function is invoked, and a function must only have one trigger. Triggers can have associated data, which is often provided as the payload of the function. And as we saw in the introduction, that we can have multiple sources of inputs that get added there. In this example here, we have HTTP, but we're bringing in data from blob storage as well. And obviously the main trigger, which HTTP is an input as well. So you can have additional inputs at the same time. Then we'll take a look here is what is a binding. And so my arrow is a little bit messed up, but the idea is bindings define if your function is connected to another service. So we have input bindings and output bindings. So the data from bindings is provided to functions as parameters. Bindings are optional, and a function can have multiple input and output bindings. Optional, but often used, which we'll find out. But let's take a look at what supported bindings are in the next video. All right, now let's take a look at what supported bindings are available for Azure Functions. There's quite a few here, and we'll quickly go through them just so you have a scope of idea. So we have blob storage, Azure Cosmos DB, or Cosmo DB. I always want to add that S in there. Azure SQL, Dapper, which is a runtime. We covered in the course. It's a runtime for distributed applications for microservices, Event Grid, Event Hub, HTTP webhook. That's going to be the most common one you'll use. IoT Hub, Kafka, mobile apps, notification hub. That's for push notifications, queue storage, messaging. RabbitMQ, that is an open source queuing system. SendGrid, which is for sending emails. Service Bus, which is both queuing and PubSub. SignalR, which we don't really talk about much in this course, but it's an open source .NET library to send asynchronous notifications to client-side web applications. Table storage, timer, Twilio. All right. And so what's also important to note, and sorry I could not make this graphic better. I really, really did try to present this better, but it's just there's so many here. But the idea is that some don't support triggers. So like Azure SQL does not support triggers, mobile apps notifications don't, table storage and Twilio does not. Then you can see we have a big gap of inputs for a bunch here and a bunch there. It's not super important to know for the exam, but the fact that you don't get triggers, inputs, and outputs across all services. And there are some cases where the API version matters. So like if you are using version 1, some things are not going to be supported, and even in some cases, version 2, like mobile apps notifications, don't have support. So in some cases, you do have to use version 1 functions, but most cases you'll be using version 4. So hopefully that gives you kind of a broad idea of supported bindings, but we're not done with bindings. We'll be looking at more of it, okay? Let us talk about binding directions. So all triggers and bindings have a direction property in the function JSON file. The direction of the triggers is always in, and the input-output bindings either is in, and, or out. And some bindings support a special direction called in-out, which is a little bit confusing, but it's nice to have a extra option. So the idea is we have a direction, and triggers, again, are always in, and then you have in, out, and in and out. The trigger is defined alongside the input and output bindings, so trigger will have the same as the input type, but with trigger appended. So for example, if we have blob, that would be our input binding, then we'd have blob trigger as the trigger, and that's how you would know the difference, right? So again, just iterating, see where it says type here. If it was just HTTP, then it would just be a binding, but if it's an HTTP trigger, then it's a trigger with also an in binding. If you use the in and out, only the advanced editor is available via the integrate tab in the portal, just so you know, because there's a visualization of integrations that we see in the Azure portal. And so they're talking about that in and out option there, okay? Okay, so now what I want to do is just go through a few scenarios of triggers and bindings to help cement the idea of their utility. So we'll take a look at our first scenario. So every hour you want to read a new log file delivered by your application, and you'll need to transform the data to be ingested in your NoSQL or SQL database that resides in CosmoDB. So here is our visualization. We have our function, which is Python for fun. It's going to output to CosmoDB, so we need a binding out to there. It has a trigger here that gets triggered by an HTTP request to the timer, and we got the blob storage. So you use a trigger timer. I guess actually HTTP shouldn't even be there. I think that's just a mistake. But you use a trigger type timer because it's a scheduled job that will run at a specified time. The trigger will be in for the blob storage and out for CosmoDB because whenever a function runs, it'll be on a timer, and when it executes, it'll read data from blob storage, process the data from blob storage, and then write some data in CosmoDB. So the key thing here is that this runs on a schedule. You're not, even though it's there, you're not invoking it like with an API request. It's just invoked on schedule. Let's take a look at scenario 2. Every time someone signs up to your application, you want to trigger an email. So here there is an HTTP request coming in, and it's going to send out to SendGrid to send out that email. So you want to develop an API that allows you to send an email after a request is received, and you'll use HTTP trigger because it's an API that will be triggered based on this request. For the bindings, you won't be accessing any data when the function starts, so the in direction is none, and you'll use SendGrid for the out direction, which allows you to send messages via email. Looking at our third scenario, consider a scenario in which you're using a queue service and you want a function to process a storage message in one queue and enter a new message in another. So the idea is you have a queue, again, it's triggering something, and it's going to output to something. So in this case, you'll want to use, it says, consider a scenario queue service where you want a function to storage message in one queue and enter in another. So probably, this icon's old, but we probably should have had this icon repeated twice, because this is the SendGrid logo. So just imagine that we took this icon and we put it over here. Very sorry for that graphical error, but the idea here, in this case, you want a trigger type of queue and a binding type of queue for the direction out, because you're not accessing the queue in the in direction. You read the data from one queue and process it to create a new message, and then to write to a different queue, which may or may not be connected to another service or function. So there you go. All right, let's take a look here at binding expressions. So in function JSON file and the function parameters code, you can use binding expressions that resolve to values from various sources. So most expressions are identified by wrapping them in curly braces. I say most because there's an exception where you do not use curly braces. But the idea is that it allows you to have kind of dynamic content within your function JSON file. And there are a variety of different binding expressions. We have app settings, trigger file name, trigger metadata, JSON payloads, GUID, current date and time. Let's go take a look at what those look like. The first is app settings. So when you want to change configuration based on the environment, you're going to use percentage signs. This is the only case where you use percentage signs. It's confusing because it's the first example instead of curly. So notice that there's percentage signs there. And then for trigger file name, this can be used to change the path of a file name. Works for both in and out directions. So here we have the curlies here to say for the file name. For trigger metadata, many triggers provide additional metadata values. These values can be used as input parameters for C#, F#, or properties for context bindings and objects in JavaScript. So for example, if we're doing Azure Queue Storage, trigger supports the following properties: queue trigger, dequeue, ID, etc., etc. And then you'll notice that they are available here. So see, queue trigger is here, queue trigger. It's typed in camel case mode. For JSON payloads, when a trigger payload is JSON, that means the data being passed is JSON, you can refer to its properties and configuration of other bindings in the same function in the code. So, if the payload was blob name and then hello world.txt, you do blob name and that would put that here. Okay. And if some of your properties in your JSON payloads are objects, you can use the dot notation. So that's just a common thing for JSON or JSON or JavaScript. For if you want a globally unique identifier, you can just do a rand GUID and you'll get something that looks like that. If you want to have the current date and time, you do date time. You're going to get the current date and time in this format. So there you go. Let us take a look at local settings file. This is a file we saw when we were looking at the anatomy of the local files. And so the local settings file stores app settings and settings used by your local development tools. This file is called local.settings.json and is expected to be at the root of your project folder. Because the local settings JSON may contain secrets such as connection strings, you should never store this in a remote repository, so make sure you add it to your .gitignore file. Here is an example of one. So first we have is encrypted, so when the setting is true, all values are encrypted with the local machine key. For values, these are a collection of application settings used when running a project. So notice we have function worker runtime, Azure Web Storage or job storage, my binding connections, things like that. The host customize the function's host process when you run it locally. And then connection strings used only by frameworks that typically get connection strings from the connection strings area there, okay? Okay, so Azure Function Core Tools lets you develop and test your functions on your local computer from your command prompt or terminal. So it's a CLI, and you type in func, and it allows you to do a whole host of things. So let's take a look at the commands we have for top-level commands. We have init, so create a new function project in a specific language. Logs, get the logs for functions running in Kubernetes cluster. New creates a new function in the current project based on a template. Run enables you to invoke functions directly, which is similar to running a function using the test tab in the Azure portal. Start starts the local runtime host and loads the function project in the current folder. Deploy, which was replaced with function Kubernetes deploy. Then we have command groups that contain their own set of subcommands. So we have func Azure. So this is when you're working with Azure resources, durable for durable functions, extensions for managing extensions. If you're working with Kubernetes and Azure functions, you can do that. If you are messing with settings, you do settings. If it's with templates, for list available templates, you can do that. So there you go. All right, let's talk about custom handlers. These are lightweight web servers that receive events from function hosts, and they can be written as long as it supports HTTP primitives. And these are really great in situations where you want to have a runtime that is not supported for like a language like Go, Rust, Ruby, or a runtime environment for a specific technology where you need a bunch of libraries preloaded like Ruby on Rails or Deno. And so within your function JSON, the idea here is you'll have a custom handler section, and this is going to just basically define the execution path, because it basically is running a program. Custom handlers, you can use triggers and inputs and output bindings via the extension bundles. Okay, so let's kind of visualize that so we really understand that this is like a separate thing that's running. So the function will pass along the payload to the custom handler. The communication between the function and custom handler is via HTTPS, request and response. The custom handler runs on lightweight web servers. The underlying compute will likely vary based on what service plan is chosen. So it's going to be other places. I couldn't really figure out where they were. The custom executable for the custom handler is bundled along with your function code. So there's that there. Some things about the application structure. To implement a custom handler, your application must have the following: a host JSON file, a local settings JSON file, a function JSON file, a command script or executable which will run on the web server. And then the following diagram shows how these files look on the file system for a function named myQ and a custom handler. So here you can just kind of see, it's not the prettiest, but I mean, it gets the point across. The idea is you have a folder, here's your function JSON, and this one happens to use an executable. In practice, custom handlers are super, super hard to do. And I think I mentioned this before, but I was trying to set up a Ruby one and it didn't work. And I tried to set up the tutorial one that's in the docs for Rust or Go. That didn't work. I reached out to the person that made it. That didn't work. I reached out to Azure support. They didn't know how to do it. So if people are running custom handlers, if anyone figures it out, please tell me. Hopefully I do figure it out and we get it included in this course. If we don't, just understand if I couldn't do it, then it's not a big deal if you don't know how to do it, okay? But for me, I personally would have loved to run Ruby because that's my favorite language to use. And that's what I would use on Azure Functions. Okay, so let's say you are making a custom handler and you deploy it and you end up having an error that says runtime is unreachable. What do you do? Well, not a whole lot, but I can tell you that there are some things that you can narrow down because a runtime could not be running for multiple reasons. The idea is that the runtime couldn't start. And so there are some common reasons that Azure suggests that it could be. So it could be storage account was deleted, storage account application setting was deleted, storage account credentials are invalid, storage account is inaccessible, daily execution quota is full, app is behind a firewall. So there are your possible reasons for things to go wrong. And I just wanted to share that, I ran into this and I didn't necessarily get through it, but I wanted to share to you possible solutions, okay? Hey, this is Andrew Brown from Exam Pro, and we are taking a look at durable functions. So durable functions is a serverless compute extension of Azure Functions that allow you to write stateful functions. The extension introduces two types of functions. So we have orchestrator functions. This defines stateful workflows implicitly representing state via control flow, and entity function, which manages the state of an entity explicitly representing state. They define workflows in code, so no JSON schema or designers are needed. But honestly, I would like one because other providers like AWS have no code solutions. So it's kind of weird. They try to make it sound like an advantage, but it isn't really an advantage. They can call out functions synchronously and asynchronously. The output from the called functions can be saved to local variables. They automatically checkpoint their progress whenever the function awaits. Local state is never lost if the process recycles or the VM reboots. So durable functions currently support the following languages. So we have for C#, JavaScript, Python, F#, PowerShell, and PowerShell 7. To use durable functions, you need to install a library specific to your language in the root of your function app project, such as npm install durable function. So there you go. All right, so if we are going to be having stateful functions, we are going to need a variety of different patterns for setting up different kinds of serverless workloads. So let's take a look at them. The first is function chaining. So this is the pattern of executing a sequence of functions in a specific order. Often the output of one function needs to be applied to the input for another function. Durable functions allow us to implement this pattern concisely in code. Then you have fan out, fan in. So this is a pattern of executing multiple functions in parallel and then waiting for them all to finish. Fanning out can be completed with normal functions by having the function send multiple messages to a queue. Fanning in is much more difficult because we have to write code to track when the queue triggered functions and store functions output. The durable function extension handles this pattern with relatively simple code. We have async HTTP APIs. So this pattern addresses the problem of coordinating the state of long-running operations with external clients. A common way to implement this pattern is to have an HTTP call trigger the long-running action, then redirect the client to status endpoint, Then they can pull to learn when the operation is complete. Durable functions provide built-in APIs that simplify the code we write for interacting with long-running function executions. The monitor pattern refers to a flexible recurring process in a workflow, such as pulling until certain conditions are met. A simple scenario such as a periodic cleanup job can be addressed with a regular time trigger, but its intervals fixed, making managing instance lifetime difficult. Durable functions enables flexible recurrence intervals, task lifetime management, and the ability to create multiple monitor process from a single orchestration. A little bit more here. So we have human interaction. So many automated processes involve some form of human interaction. Humans are not always available and responsive as cloud services, which makes invoking humans in an automated process tricky. So automated processes must allow for this, and they often do so by using timeouts and compensation logic. Then we have aggregators, so stateful entities. This pattern is about aggregating event data over a period of time into a single addressable entity. The data being aggregated may come from multiple sources, be delivered in batches, or may be scattered over long periods of time. The aggregator may need to act on event data as it arrives. External clients may need to query the aggregator data. So there you go. Let us take a look at Azure functions on Kubernetes. Now, I don't think this is on the exam, but I just thought it was a very interesting thing that Azure functions can do. And so I just kind of wanted to run quickly through it. So you can deploy any Azure function app to a Kubernetes cluster running on KEDA. If you don't know KEDA, it is Kubernetes event-driven auto-scaling service. It allows you to set up auto-scaling based on events from various cloud-native services and third-party services. So in this case, it could be for Azure function apps. And so when we were looking at the core tools, Azure Power Tools, whatever you want to call it, they had the option to deploy to Kubernetes. So I'm going to assume that you'd probably be running an AKS, Azure Kubernetes Service. But let's just read through some of the things here. So Kubernetes-based functions provide the functions runtime in a Docker container with event-driven scaling through KEDA. KEDA can scale into 0 instances with no events occurring and out to n instances, so it scales to 0. It does this by exposing custom metrics for Kubernetes autoscaler, so horizontal plot autoscaler. Using function containers with KEDA make it possible to replicate serverless function capabilities in Kubernetes cluster. These functions can be deployed using AKS, virtual node features for serverless infrastructure. I'm really curious like how they're running and like other things there, but that's outside of the scope of this course. But if you're into Kubernetes, and I do have a Kubernetes course, it's just interesting to see that that is a functionality there. And so I just wanted to call that out for our Kubernetes fans, okay? Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Virtual Machines, which makes it easy for you to choose your own OS, compute, memory, and storage, and launch a server within minutes. All right, so let's take a quick look here at VMs for Azure. And this is a highly configurable server that relies on virtualization, meaning that you're running a server without having to actually buy and maintain physical hardware that runs it. You will still have to manage things at the software layer. So you would have to apply your own OS system patches and installing the configuration packages. But the nice thing is that you're not dealing with that hardware. It's just going to work for you. And some things I want you to know about Azure Virtual Machines is that the size of the virtual machine is determined by the Azure image. And so the image defines the combination of vCPUs, memory, and storage capacity. The current limit on a per subscription basis is 20 VMs per region. I would think that if you wanted more, you could just use another subscription. I don't know if they have a service limit increase for that, but that might be possible as well. Azure VMs are billed at an hourly rate. An instance or a single instance that you launch is going to have availability of 99.9% when you're using premium disk. If you have standard disk, I have no idea what it is, but it's going to be less than that. If you want to get 99.95% availability, you're going to have to launch 2 instances within an availability set, and you can attach multiple managed disks to an Azure virtual machine. Now, just to give you like a quick visual of what's actually happening when you launch an instance, because when you do launch a virtual machine, there's going to be other networking components that are going to be created or associated with you, and you definitely need to know all these components here. So I have this nice diagram, and we're going to do a quick run through with it. And I want you to just know that when you do launch a virtual machine, it actually does give you a list of all the components that it creates. This is actually very common with most Azure services, and sometimes what they'll do is they'll put it within a resource group for you so that they're all grouped together, which is very nice. But let's just run through these common components that you need to know, such as the network security group. And this is going to be attached to your network interface. It acts as a virtual firewall with rules around ports and protocols. So that is what's protecting our virtual machine. You have the network interface that handles IP protocol. So that's how the virtual machine talks to the internet or other things on the network. You have the virtual machine itself, or the instance. That's the version or the instance that is currently running. It's going to get a public IP address assigned to it. So that's how people from the internet can actually access the virtual machine. And then you're going to have to launch it within a virtual network. And so you're going to have that VNet. So you'll either choose one or you'll be creating one during that wizard process. So there you go. So now let's take a quick look at the options for operating systems on Azure VM, and let's just define what an OS is. So the OS is the program that manages all other programs in a computer, and the most commonly known operating systems are Windows, Mac OS, and Linux. And when you want to launch a virtual machine, the way you determine what operating system you use is based on the image that you choose, okay? And Azure has a marketplace, so they have so many different kinds of operating systems. You're going to have every possible option you want. And Microsoft has also partnered with specific companies to make sure that they're providing you images that are updated and optimized for the Azure runtime. So let's do a quick run through of these supported or partnered OSs. So we have SUSE, we have Red Hat, Ubuntu, Debian, FreeBSD. Then you have Flat Car Container Linux, Rancher OS, which is for containerization, Bitnami. Bitnami is more like images that have preloaded software on them. They're very popular for their Bitnami WordPress. You have Mesosphere, and then you have images that have Docker with it. So you have a lot of options open to you there. And I always forget about Jenkins, and Jenkins is on the end there. Now, if you want to bring your own Linux version, you can totally do so. All you have to do is package it into a virtual hard disk or a VHD. If you've never heard of VHDs, these are just virtual hard disk formats that you can create using Hyper-V software, which would be on your Windows machine. And just be aware that Azure doesn't support VHDX, which is a newer format. It only uses VHD. Okay, so there you go. So let's take a quick look here at Cloud Init, and this is something that's not going to be on your exam, but it's something you absolutely should know and need to know because it's an industry standard, and it's just something that you might, like if I didn't show it to you, no one's going to show it to you, so let's just get to it. And so Cloud Init is this multi-distribution method for cross-platform cloud instance initialization, and it's supported across all major public cloud providers, so Azure, AWS, GCP, provisioning systems for private cloud infrastructure, and bare metal installations. So what is cloud instance initialization? Well, this is the process of preparing an instance with configuration data for the operating system and the runtime environment. And so the idea is that you're going to have cloud instances that are initialized from a disk image and instance data, right? So the image is whatever the VM image is, but you're going to have data such as metadata, user data, and vendor data. And I'm not going to get into all the data. I just want you to know the one, which is the one you'll be working with, is user data. And so user data is a script that you want to run when an instance first boots. And so if you've ever used AWS and you launch an instance, you'll see a box in the wizard that says user data, and that's what this is. In Azure, I don't think they make it as clear. I don't think they call it user data, but if you're pragmatically doing it with ARM templates, when you're doing infrastructure as code, that is what you're doing. You're using Cloud Init underneath. I just wanted to make that association to you. So when you see that word user data, you think Cloud Init. And so Cloud Init really only works with Linux distributions. So it should work with all the Linux distributions on Azure. I pretty sure it's not being used for Windows machines, but there you go. Azure virtual machines come in a variety of different sizes that are optimized for specific use cases. And the way Azure groups these are into types. So that would be like general purpose, compute optimized, and sizes. And sizes is kind of a weird word because I've seen in other places in their documentation called series or SKU family. So you'll see me using those three terms interchangeably. They definitely confused me when I was looking at it at first. But let's just go quickly through some of them. There's a lot of them, so they're not going to be all of them on the list here, but we'll just quickly go through it. So the first is general purpose. These are balanced CPU to memory ratio, testing and development, small to medium databases, and low to medium traffic web servers. This is pretty much what you're going to be using unless you work for a company that has a lot of money. And the one you're going to see the most is called B1 because it's super, super cost effective. And that's the one I'm always using when I'm launching Linux machines. And you'll see me using it through follow-alongs here in this course. The next one here is compute optimized. So that's high CPU to memory ratio, good for medium traffic web servers, network appliances, batch processes, and app servers. So this just has more CPU here. The most common one is the FSV2 or the F series. Then you have memory optimized, so high memory to CPU ratio, great for relational databases, medium to high large caches, and in-memory analytics. And we have a variety of SKUs there. Then you have storage optimized. So these are high disk throughput and ideal for big data, SQL, NoSQL databases, database warehousing, and large transactional databases. And we just have LSV2 for those. Then you have the specialized ones for GPU for heavy graphic rendering, video editing, model training, and interferencing with deep learning. So available with single or multiple GPUs. And so we have a variety of SKUs there. And then you have your HPCs, your high performance compute. And these are the most fast and powerful CPU virtual machines with optional high throughput network interfaces. All right. And I just want to point out that there are more here. But I'm just showing you ones that are current. So there are previous series here, like we're not showing basic A, all right? Like the A series is not being shown here. Now, when you want to actually go see this full list here, it's very easy. You just launch up a virtual machine and you're going to be able to choose two things. You're going to choose the image. So that's going to be what do you want to run, right? So it's going to be Ubuntu or Windows machine, and then you're going to choose your standard size image. I believe that if you choose certain images, not all sizes will be available to you because some images have to be optimized for those series. Sorry, I'm just drinking some tea here. And so there's that B1 series, and you can see in Canadian dollars, it's $9.72, which is a pretty good price for me. And you can explore all the costs in Azure, which is really nice. You don't have to go to a separate marketing website. You can just open it up, and you can just sort by the lowest cost, which is what I always do. And they have a lot of filters there. So there you go. Let's quickly talk about Azure Compute Units. So Azure Compute Units, also known as ACUs, provides a way of comparing compute, so CPU performance across Azure SKUs. And remember, we said SKUs is the same thing as sizes or series. So you'll just see us varying the terms on that. ACU is currently standardized on a small, so standard A1. And you saw prior that A1 is a previous series. So it's not something that you generally be launching, but everything's based off of that one. And those are given a value of 100. It's just an arbitrary number to give it a points against other machines. And all other SKUs then represent approximately how much faster that SKU can run a standard benchmark. I don't fully understand the math behind their stuff here, but I generally get the idea here, and I'll just show you quickly a quick comparison. So here we have the A1 to A4 series against the D1, D14 series. A1 is our baseline at 100 ACUs. And it has a ratio 1-to-1 from vCPUs to core. And so you can see that for D1 to D14, it says 160 points to 250 points. And so if I did the math here right, I think I did, it's going to be basically 60% to 150% more performant than choosing an A1 to A4. So that's how that works. So there you go. So here's a neat feature that Azure Virtual Machines allows you to do, and you can actually do this with a lot of different services with Azure, and it's the Azure mobile app. And so what you'll notice is that when you're using virtual machines, they might have this little QR code, and if you have the app installed, what you can do is scan that code. But honestly, you don't even need to scan the code. If you just have the app installed, connect to your account, you can log in on your phone and check out the virtual machine, how it's performing, and you can take basic actions there. And I believe as well you can access the Cloud Shell. So it's pretty darn cool. And so I just wanted you to know about that. And if you haven't, just go ahead and install it on your phone. I think it's available for Android and iOS. I have an Android phone, so I didn't check iOS, but yeah, go check it out. So sometimes when you're launching a virtual machine, you'll have the option between generation 1 versus generation 2 when you're choosing images. And I want you to know about this stuff here. And to understand it, we need to know a little bit about Hyper-V. So Hyper-V is Microsoft's hardware virtualization product, and it lets you create and run a software version of a computer called a virtual machine. And each virtual machine acts like a complete computer running an operating system and programs. And so if you're still kind of wondering what Hyper-V is, if you've ever heard of VirtualBox, which is used for running VMs on Mac and Linux, this is basically the exact same offering. It's just Windows offering, okay? And it already comes pre-installed on Windows 10. So you might have to toggle something on. I can't remember it because it's been a long time since I've had to configure it. But the point is that you have a Windows machine, you're already ready to start using Hyper-V. And Hyper-V has 2 generations of virtual machines. So the first one was generation 1, and this will support most guest operating systems. And then generation 2 supports most 64-bit versions of Windows and more current versions of Linux and FreeBSD operating systems. And there are these 2 here, but neither 1 or 2 is bad. So they both have their own use case. So it's not like you should always use 2. And there's a big list online, but we're not going to get into that full list. But anyway, so we see that Hyper-V has generation 1 and 2 VMs, but Azure also has them as well. But they're not one-to-one the same as Hyper-V generation. So if you look up Hyper-V, like the Hyper-V generation feature set, you might not have that in Azure, so I wouldn't rely on that list. But what I definitely want you to know between Azure Gen 1 and Gen 2, that's a key difference, is that Gen 1 is BIOS-based architecture, and Gen 2 is UEFI-based boot architecture. And if you've ever built a video gaming machine, you definitely know the difference between these 2. If you don't, it's just the way the machine boots up. It's the first screen you see. And it's going to change what kind of configuration options you have. And UEFI has a lot of great features in it. So, for instance, it has Secure Boot, which verifies the bootloader is signed by a trusty authority, and you can have larger boot volumes up to 64 terabytes. And if you want to know more, you'll just have to look up UEFI because I'm not covering it in this course. I just want you to know that's the key difference there. And Hyper-V VMs are packaged into virtual hard disk format. So that's going to be either VHD or VHDX files, okay? One thing you might want to be able to do is actually get into your virtual machine. And we have a lot of different options available to us. In fact, we have 3 ways to connect to our virtual machines. We have RDP, SSH, and Bastion. And so if you don't know these things, we're going to walk through them right now. The first is Secure Shell, and this is a protocol to establish a secure connection between a client and server. This is how you can remotely connect to a Azure virtual machine via a terminal. SSH happens on port 22 via TCP. Port 22 is something you should absolutely remember as SSH. And you will generally use an RSA key pair to gain access. You can also use a username and password, but most people don't do that anymore. Another way of getting access to your machine is by using RDP, which is Remote Desktop Protocol. This is a proprietary protocol developed by Microsoft, which provides a user with a graphical interface to connect to another computer over a network connection. Basically, what it means is that it's going to open up a window, and you're going to be able to see like another Windows desktop in it and control it remotely. So this is how you can remotely connect Windows Server to a virtual desktop. RDP happens on port 3389 via TCP and UDP. I think there might be some other ports, but this is the port that you need to know. I just remember from AWS because there were some extra ports I had to configure, but that's a different story. Then you have your Bastion, which is your third option. And so Azure Bastion, which is actually an Azure service, is a service that you can deploy, lets you connect to a virtual machine using your browser and Azure portal. And so the reason why this is so useful is that if you have, let's say, a Chrome desktop, which doesn't actually, it can't actually use SSH client, or it can't use the RDP client. This just gives you another way of using the browser, so you don't have to install those clients. But we'll get into that shortly here, okay? So let's take a closer look at SSH, and the most common way to access your VM or to authenticate yourself so that you're allowed to get into your VM with SSH is by using a SSH key pair. And so the idea is that you're going to have to generate out 2 keys. That's why it's called a key pair. There's 2 keys. And so you'd use that command ssh-keygen-trsa. And that is something that is definitely etched in my memory. It's definitely something you want to memorize because it'll be with you throughout your entire career. And so you're going to have a private key and a public key. And so the way these keys work is that the private key should remain on your local system and not be shared with others. And the public key is going to be stored on the VM. And when you go ahead and SSH, you're going to provide your private key as part of the SSH command. And it's going to try to match it against the public key to authenticate you. And so that is what you normally do. You do SSH-I, provide the public key. See where it says .pub? That's how you know it's a public key. And then there's the actual address of the server. And that's how you're going to gain access, okay? So let's take a look at the process of using RDP. So the first thing you'll want to do is download the RDP file. So when you go and try to connect to that virtual machine, you're going to go ahead and download the RDP file. That's going to download this RDP, this file that has an RDP extension. You're going to double click that file, and you're going to be prompted to fill in your username and password. This username and password is what you specified when you created your virtual machine. And I just want you to know that if you are on a Mac, you can install the remote desktop client from the Apple Store. But if you're on Windows, you already have RDP client installed. There's nothing extra that you have to do. So let's take a closer look here at Azure Bastion, and this is an intermediate hardened instance that allows you to connect to your target server via SSH or RDP, and it will provision a web-based RDP client or SSH terminal. I'm going to tell you, honestly, I never really thought of this use case for Bastions prior to this, but the reason like Bastions are good or have still a utility these days is because some people are using a Google Chromebook, and they're not going to have a terminal, so they can't use SSH, or if they're on Windows, they can't install the PuTTY client, or if they're on Windows, they can't, they won't have the remote desktop client. And so the only way is through the web, because a Google Chromebook's all a browser. And so this is one of those utilities for a Bastion. Now, Bastions don't necessarily are just for this use case. They're definitely a very good and secure way to connect to your virtual machines and having a way of auditing who has access to what. But this is the use case that Azure is putting forward with Bastion here. And so the idea is that when you want to create a Bastion, you're going to have to add it to a subnet in your VNet, or you're going to have to make a new subnet, and it has to be called Azure Bastion subnet, and it has to have at least a size of /27, so 32 addresses. So that's what you're going to have to do. So you'll just have to go in and add in that subnet there. And then once you do, you can go ahead and launch your Bastion. So let's first take a look at RDP. And so RDP, we saw how to do it, but let's see what it looks like with Azure Bastion. So what you do is you say connect with Azure Bastion for your Windows machine. That's going to assume that you want RDP. You're going to just put in your username and password as you normally would, and boom, you're in your machine. That's all it takes. Let's take a look at how you do it with SSH. So, you know, if you're using a Linux server, it's going to obviously want to use SSH because you don't have RDP for that. And so you can actually use either the SSH private key or the username and password. I recommend using always SSH private key. But let's take a look at that process. So you'll enter your username in, and then you can switch over to SSH private key. And then the .pem file, which is downloaded locally to your machine, which is your private key, you can just select it, and then that will upload it and use it in the comparison, and boom, you're in your machine. So that's just kind of a cool service that they have there. Let's just do a quick comparison between Windows and Linux servers. This is going to be very obvious for people that are used to running Windows workloads, but for those who grew up on Linux, I just want to make sure you understand some of the caveats of Windows that you might not be used to. So obviously Azure allows you to run both Windows and Linux instances or VMs. And so let's just talk about Windows first. So when you launch a Windows server, just like your desktop computer, it needs a Windows license to run, whether it's Windows 10 or whatever Windows server you're using. But I just want you to know that when you launch your server, you don't necessarily have to have the license on hand. And so if you launch a server without a license, all it's going to do is say Windows is unactivated, and you're going to have to take some manual step to activate that license. And I just want to tell you that so that you're not afraid of launching a Windows machine because you think you're going to get charged a license fee. It's not going to happen. You have to take some manual intervention to do that. So do not worry about launching that Windows machine. You can bring your own license via a hybrid license. So some people, enterprises, already own their licenses, and they just want to, they already made a deal with Microsoft, and so they just want to reuse those instead of using whatever Azure provides because it can be cheaper. You're going to set a username and password because you're using RDP to access the machine, so you're not using your SSH key pairs. Windows machines require larger instances, okay? So if you're running Windows 10 or whatever, it needs a lot more memory, and so you're going to have to run it on a B2, which is a lot more expensive than a B1, and that's because it runs a full desktop environment. All the Windows servers do this, and so this is generally why I like running Linux. So just be aware not to keep your Windows server running for very long if you don't have a lot of money and you're just learning to pass the certification. Let's talk about Linux really quickly here. Most versions of Linux require no type of license. So I think like you can get Red Hat, you might need a license for that if you want support. You set either a username, password, or SSH key pair. You can utilize smaller VM sizes because you're not running a full desktop experience. Could you run like a full desktop experience? Possibly. I haven't ever tried to do it on cloud myself. Unix and Linux-based systems traditionally are terminal-based environments, right? So you're going to be SSHing into them, and you're not going to have something visual. Okay, so there you go. So let's talk about update management. At the start of this section for virtual machines, I had said that there was some requirements, ongoing software patches and things that you had to perform on your virtual machines. And so that is something that you have to take care of. But if you wanted to automate that process, this is where you can use update management. So that's what it'll do. It will install operating system updates and patches for both Windows and Linux. And not only can it do it for your virtual machines on Azure, but it can do it on-premise and even in other cloud providers, okay? And the way this is going to work is you're going to go to your Operations tab where it says Guest plus Host Updates, and you're going to click on Update Management. Now, Update Management looks like it's its own service, but it's actually using Azure automations underneath. And so that's what is installing the agent. And the agent is the Microsoft Monitoring Agent, MMA. So that's how it knows what to do. You have to get that installed in your machine. So Update Management will perform a scan for update compliance. A compliance scan is by default performed every 12 hours on a Windows machine and every 3 hours on a Linux machine. It can take between 30 minutes and 6 hours for the dashboard to display updated data from managed computers. And I just wanted to point out a little bit about Azure Automation. So, because it does more than just obviously update management, but Azure Automation, you can enable update management, change tracking, inventory, start-stop VMs during off-hours features for your servers and virtual machines. And these features have a dependency on a log analytics workspace and therefore require linking the workspace with an automation account. So there is a little bit extra that we have to have, but there you go. Hey, this is Andrew Brown from Exam Pro, and we're going to be launching our own Bastion using Azure Bastion services. So there's two ways to set this up. We can go to Bastions over here and create a Bastion this way, or we can create one after we've created a virtual machine. I prefer the latter, so let's go ahead and do that and launch ourselves a new virtual machine. And so we could either launch a Windows server or a Linux server. Today I'm going to be launching a Windows server. And what we'll do is go down here. I'll make a new group. We'll call it the Enterprise. And as we do that, we'll just name this Enterprise D. And we'll launch that in Canada or US or Central US. That's fine with me. 2019 Data Center Gen 2 is totally fine. If you go here, you're trying to find it, you go hit select. And we'll choose Gen 2 data center. It is expensive, but we're not going to be using this for very long. For the username, I'm going to put data. And for well, we'll just make it Azure user to make our lives a bit easier. And then we'll put testing, capital T, 1, 2, 3, 4, 5, 6. Testing, 1, 2, 3, 4, 5, 6. And we will go down below. We're fine with these settings here. We're going to go next to disk. We're going to leave the disk to premium. That's fine. We'll let it create a new network. That's totally fine. Management is okay, and we'll just actually go hit review and create. And now we'll just hit create so that it will go ahead and do that. It'll tell us that it's in progress. And we'll just wait a little bit here. I'll see you back in a moment. All right, so our instance is ready. So let's go ahead and go to this resource here. And then on the left-hand side, you'll have connect. And so I'm going to show you, and it's not necessary for you to do this step because I'm going to show you how to connect via the Bastion. But I'm going to go ahead and download this file, the RDP file. And this will only work if you're on Windows, by the way. Well, I guess it'll work on Mac, but you'd have to install the RDP service that uses with Windows there. And so here, this is Azure user. We're going to type in testing with a capital T. Just double check that there. I'm going to log in, make sure that this works. We'll do that one more time. Oh, it's testing 1, 2, 3, 4, 5, 6. There we go. We'll say yes. And we'll just make sure that we can remote desktop into this just before anything else. And there we go. So that's all good to me. I don't need to see any more. We'll go over to Bastion. We'll say use Bastion. And this is going to set up a Bastion service. In order to use Bastion, you need to have another address space defined for it. It makes it really easy to make it here. So I'm just going to go 10.0.1.0/24. And we'll go ahead and hit OK. And so down below, it's going to choose an address space. We have a net security group. I'm just going to put it for none. I don't think I want one on that. And if we scroll on down here, we have the resource group. So we're going to put it in the same resource group, and we'll go ahead and create that. So now before this, they didn't have this really nice wizard. You used to have to go and create all those things individually in your virtual network. But this is really nice. It does take a bit of time for this to provision. So I'll see you back here in a bit. That took a bit of time for that to create that Bastion, but it is ready to go. And so now that we have it, we can go ahead and utilize this connection here. And so right away, I think it's setting up for RDP here. So what we'll do is type in Azure user. And then capital T testing 1, 2, 3, 4, 5, 6. We'll go ahead and hit connect. And so notice that I didn't have to use an external application. I could just run it in right here. It's all in the web browser. So that's pretty much how the Bastion works. I can't remember the pricing on Bastion. I think it's a little bit of money, so I don't want to keep this laying around here. But this is great if let's say you're on a Chromebook, which are becoming really popular, where you can't install native applications. Or you're just having issues because you're on like Linux or something like that. So there you go. That's all there is to it. We'll go ahead and clean this up. And so I'm just going to go here, find the resource group, and we'll go ahead and delete. I'm just making sure that Bastion's within there. So it is good. And there we go. So we just launched a virtual machine for Linux. Now let's go ahead and launch one for Windows. So I'm going to go to the top here and type in virtual machines. We'll go to the first link. I'm going to hit add virtual machine. And what we'll do is we'll create a new group. The last one I had was called Azure. I'm going to call this one Cardassia. And I'm going to name this machine also named Cardassia. And this time what we want to do is we want to move over to a Windows server. I find the easiest one to learn with is the Windows 10 Pro server, just because I find these ones a little bit daunting. So I'm going to go Windows 10 Pro. And then what we're going to do is go choose a larger size. This is not going to work. We cannot run a Windows server on a B1LS, so we're going to have to go a little bit larger. And we don't have to go too much larger here, but the idea here is that there's going to be a more expensive spend here. So we're not going to be running to keep this running for long. But here we have the B2S. That is the appropriate size to run this. Anything smaller I don't think is going to work. And we are going to put in a password here. So I'm just going to put in Cardassia. And we'll do Cardassia 123. Put a capital on it, I guess. We'll just do this here. And I'm just going to go back and lowercase this one. And we're going to allow the inbound port of 3389 because that is what RDP needs. I'm going to confirm that I have a Windows license. I actually don't, but the thing is you can still launch one for your test purposes. It'll just complain saying you're not activated. So there are some limitations, but it's good enough for us to learn, okay? And so now that that is all great, we'll go next to disks. We're going to go with premium or standard SSD this time. We are going to go ahead and hit next and go to networking. It's going to create us a new VNet, which is a great idea. We're going to let it create a network security group on the NIC, just like before. We'll go ahead and hit next. We'll leave all these options alone. This all seems fine to me. And we'll hit next, review and create. And we'll go ahead and create this server. All right, and so that's going to go ahead and create it. So I'll just see you back here in a moment when that's done deploying. All right, and so after a short little while here, it looks like our Windows server is now deployed. So what we can do is go to that resource. And if you wanted to see what it's deployed, it's the same stuff as always. You have your network interface card, your virtual networks, NSG, the IP address. But let's actually go to that resource now. And so let's see how we can gain access to this virtual machine. And so what we can do is use RDP. Luckily, I am on a Windows machine, and so I already have the RDP client that I can use. So all you got to do is download the RDP file. And then once we have that file, I can just double click it and I can open this up. If you're on a Mac, you can download the app in the App Store. And so I'll go ahead and type in my password. So my username was Cardassia. And then my password was capital CARDASSIA 123. We'll hit OK. And then it'll give us another warning. We'll say yes. And now we are in our virtual machine. So there you go. How cool is that? I'll just give it a moment to load up, but this is a full Windows 10 Pro. And as I said before, you know, we don't actually have a license. So if you're afraid of spinning it up because you think you're going to get charged a license fee for Windows, you do not have to worry. That's not going to happen. You have to do some manual intervention for that to happen. So we'll just wait a little while here for this to load. We're not using the most powerful machine, so it does take a little bit of time. And so we just hit accept here. And here we are. So we are on, we have our nice Windows machine here. Whoops. I don't know if it has any games. Let's go take a look. Maybe we can play Minesweeper. No, maybe you have to download it in the store. I'm not that familiar with Windows machines, but so there you go. So we'll go ahead and close that. And you know, if we were using the Bastion, it's the same process. You saw how we used it with SSH, but if we had the Bastion, and it's so much work to set one up, we already did that before. But all you do is enter your credentials in on the page, just as we did, and it's just a lot easier that way. So let's go ahead and just tear down this machine. We're all done with it. So I'm just going to hit delete. And if we find that resource group, we should be able to easily delete them all. I find the easiest way is to go up here, go to all resources, and then there's the resource group there, and then hit delete resource group, and then I'll type in the name of it, which is Cardassia, and I'll delete all those resources. But after that's done, always just take a double check on your all resources tab, and just make sure that those resources are gone, because sometimes they stick around. But there you go. That's as simple as it was to launch a Windows machine. Hey, this is Andrew Brown from Exam Pro, and let's take a look here at virtual machines, which I consider the backbone of most cloud service providers. And Azure keeps it really simple by calling it virtual machine. So we can go up here and type in virtual machine and make our way over here. But right now I don't have any options because I'm using a tenant that doesn't have a subscription applied to it. So what I'm going to do is go switch back to my original tenant, and this one has a subscription applied to it. And so what I'll do is just click back up here, and now we'll just type in virtual machines. And I can now see I have options of creating virtual machines. So let's go ahead and go create a Linux one first, and then we'll go ahead and create a Windows one, and then we'll see how we can connect to it, all right? So first we'll go to the top here and hit add. We'll click on virtual machine. And we're going to be presented with a lot of options, so we'll have to choose a subscription, and so there is mine. I want to probably create a new resource group here. I'm going to call this one Azure. And we'll name this Azure again. And I'm going to launch this in US East. I'll just set it to one availability zone for the time being. Then here we have what we can choose as an image. I can click on See All Images and choose from a variety of them. So if I didn't want to use Ubuntu, I could launch something else like Debian or something like that. But really, I just want to stick with Ubuntu because I'm fine with that version with 18. Then here's what really matters is the size, because that's going to affect our cost. So if we click on See All Sizes, we have this nifty table where we can sort the cost. It's just loading in the cost here. It's dynamic. This is going to be based on what your base subscription is. So if you're in Canada, you're going to see Canadian prices. If you're in the US, you're going to see US prices, et cetera, et cetera. And I care a lot about cost here, so I'm just going to sort this by cost. And here we have the B1LS, which is very cost effective. We have a RAM of 0.5 gigabytes and some other options there. So we'll go ahead and select that there. And we have a couple options. We can use SSH public key, or we can utilize a password. And so I think what we'll do is use an SSH public key because that's pretty much the standard there. We're going to name the username Azure if it lets us. Probably won't. Probably want some additional options there. Oh, but it's okay. Oh, great. And we'll go ahead and generate a new key pair. And I'm just going to name that one Azure. And we have some options here for inbound rules. So you could set to none. This is just setting up the NSG for you. But we're probably going to want to have that port open for SSH because that's how we're going to make our way back in here. If we're running like an Apache server, we'd want to have port 80 open. So we can go ahead and do that. We'll take a look at now disks. So here we have options between premium, standard, and standard HHD. I just want this to be cost effective, so I'm just going to go with standard HDD. But generally, you want to have at least standard or premium SSD when you're running real web development workloads. Then there's encryption here, and so it's always turned on by default, which is great. They also have this option of double encryption with the platform managing customer managed key. We're just going to leave that as default. Enable UltraDisk compatibility. That's not something we need to do here because we are not using UltraDisk. And here you can see that you can attach multiple disks here. So I can go and do that, but that's not something I need to do today. And some other advanced options, which we do not care about. We'll go over to networking. And so it's going to end up creating us a new VNet for us. And we'll create a new subnet for us and assign it an IP address. It will also set up a NICS network security group. So the network security group is not going to be applied at the subnet level. It's going to be applied at the NIC, which is attached to the EC2 there. And so we'll just leave it to basic. We're going to allow inbound ports for port 80 and 22. That was carried over from earlier. We can put this behind a load balancer, but I don't think we're going to do that right now. We'll go over to management. We have some additional options here for monitoring. This is all okay here. We can set it to auto shutdown. Actually, I'll leave that alone. You can also enable backups here. We'll go advanced. And now we have this option here for custom data. I covered a section on cloud init, and they don't call this user data, but most other providers will call this user data. So we could provide a bash script or additional information here if we wanted to. Then down below, there's some host group options. We're not going to worry about that. And proximity placement group. This is really important if you need to have instances nearby. I think this is pretty common with what's it called? High capacity workloads, HFC. I can't remember the initialism right now, but we covered in the core content. Then we can tag our resource here. We'll just leave that alone. I don't care about tagging too much, but generally it's good to tag in practice. And then we will get to review and create our server here. We'll go ahead and hit create. And then we'll have to download our private key so we can utilize it later. And so that's downloaded there. And now we're just waiting for it to deploy this, and I'll see you back here in a moment. So we had to wait a little bit there, and finally our deployment is complete. And we can go ahead and just review all the things that it created. So notice that it created the virtual machine, it created a network interface, a NIC for us, the NSG, the network security group, the virtual network, and also a public IP address. When I do cleanup, a lot of things I always miss are these IP addresses. And I know that Azure gave me a warning that said, hey, you're about to spend $700 yearly on IP addresses because you weren't releasing them. So when we do the cleanup step, I'll definitely emphasize about deleting those IP addresses and how to go about that. But let's go take a look at the actual resource now. So here we are, and you can see we have a lot of options on the left-hand side, such as the disk. So we can see the disk options there, and there's additional security options. Let's go take a look at how we can go ahead and connect to the server. And so there's different options here. So we have RDP, SSH, and Bastion. Since we are using a Linux machine, we're not going to be using RDP. That's really for Windows. But the trick here is that I would need to have a client on my computer to connect, like I think it's called PuTTY. If you're on a Linux-based machine, it's a lot easier. And certainly I have the Linux subsystem installed, so I could probably connect that way. But I figured let's just go ahead and connect via Bastion, because I think this is a pretty darn cool feature. So let's go ahead and create ourselves a Bastion. And this will take a little bit of time here. But we'll go ahead here and just set up a subnet. So to associate a virtual network to a Bastion, it must contain a subnet with the Azure Bastion subnet. So they actually have a special subnet for it. So what we'll do is we'll just go back to our server here, which we called Azure. And I think we can find the subnet through here. So on the left-hand side, if we go to networking, we probably could find it that way. So I'm just looking for that security group in there. It should be, maybe it's not there. If it's not there, well, you know, we could just make our way over to subnets. It's not a big deal. Because it's called Azure. It's pretty darn easy to find to begin with. And so under subnets here, what we need to do is add a special one here. And I just got to remember how this works. So you need to create a subnet called Azure Bastion subnet with a prefix of at least 27. So we'll go ahead and add a new subnet, and we'll call it that. We'll take out the space there. And the range is 10, 0, 1, 0, etc. So we'll just do it on 2. 0.2.0/27. 10.0.0.2 is not contained. Yeah, it overlaps, so we'll do 2. It's not contained in the virtual network address space. Oh, right, so we have to add the address space first. Oops, we'll just hit cancel here. That's okay, we'll discard that. We'll make our way over to address space, and we'll go ahead and add 10.0.2.0/24. That'll give us a pretty darn large range there. And so now what we'll do is go back to our subnet, and we'll go ahead and create that there. And it said it only needed 27, so we'll just give it only 27. We don't need to go bigger than we need. And that should be okay. We'll go ahead and hit save. And it shouldn't take too long. So now that we have that, we can go back here, and we'll give this another go here. It's there, so it shouldn't be complaining. Maybe what we'll do is just start from the start here again. Yeah, there you go. The Azure portal is like that a lot, where you'll have something set up and it has the old state of it. And so you just have to trust yourself that you know what you're doing, and you have to go back. But if you don't have a lot of confidence, a lot of times you'll get stuck and you'll think, okay, I don't have it right. But I always just try again and hit refresh, because the Azure portal is very inconsistent. So we're just going to have to wait for this to create. This does take a little while to create, so I'll see you back in a moment. So after waiting 5 minutes, our Bastion is now created. And so what we can do is, without even using a PuTTY client or having to use Linux directly, we can just connect via the Bastion. So here we'll see we have some options here. So we want to do SSH private key from local file. Okay. And what we can do is go ahead and select our Azure key. And then I'll just scroll down here and hit connect. Oh, and I think we made the username Azure. And we'll go ahead and connect now. And it's complaining about a pop-up here, so we'll go up here and say always allow. And we'll try that again. And then we'll say allow again. And so now that we're into our server here, let's go ahead and try to install Apache and see if we can get at least the default page running. So this is using Ubuntu. If my memory serves me correctly, it should be apt-get install Apache 2. And we'll just hit Y for continue. And we'll just wait for this to install. It doesn't take too darn long. And after a short little wait there, it finally did install. Also, if you notice this little icon here, we have a little clipboard here. I don't seem to ever use that there, so that's fine. Now, when you install Apache, we might have to go ahead and start it up. So let's just take a look to see if it actually is in the running directory here. So we'll go to cd var www. And so that's where the default directory is, right? But we can just check to see if it's running by doing a psaux. I think it's httpd, or we can say Apache here. And so it looks like it's already running, so that's pretty great for us. And since it's running on port 80 and we've opened up port 80, we should probably be able to access that here. So let's go back to our actual virtual machine. So we'll go to virtual machines. And we have that virtual machine running. I'm just going to click into it because I just want to find out its public IP address. So here it is there. And if we're lucky, this will just work. Just a copy to clipboard button right there. And look at that, we have the default page. Isn't that cool? So that's all there really is to it. And I could even update this page. You don't have to do it, but I'm just going to update it for fun. Actually, I probably have to restart the server, so maybe I won't do that. But yeah, so we connected through the Bastion, so that was pretty darn easy. We probably could have also used the Cloud Shell to connect, but maybe we could give that a go as well. Since we're all done here, let's go ahead and do some cleanup. The first thing I want to do is, the easiest way is actually to go to all resources here on the left-hand side. And this really gives you an idea of everything that's running in your account. So I actually have other stuff in here that's not relevant. But the idea is that all of our stuff is running within a resource group. And so I'm just taking a look there. I'm not seeing, this is all resources here. Let's see if you see resource group here. Yeah, they're all there right there. So I can go ahead and click that. And so everything more or less should be self-contained within here. See all that stuff? You can even see the VNet is part of it as well. And so if I go ahead and delete this resource group, it should delete all this stuff. So I'm just going to type Azure to confirm. And we'll go ahead and delete. And that should do a good job of cleaning up all those files. I'm not sure if it'll delete the IP. It should right there. But if it doesn't, what I recommend is after everything is deleted, just go back here to all resources and just double check to make sure they all vanish. Because when this is done, they're all going to start to vanish from this list. And if there's anything remaining, you'll know because it's still here, right? So just be careful about that. That's all I want you to know. And so that's the Linux part. And so let's go ahead and actually now set up a Windows server. Hey, this is Andrew Brown from Exam Pro, and it's really important that we know how to monitor our virtual machines so we can kind of check their performance or do some diagnostics on them. And so a couple of things we're going to look into. We're going to set up some virtual machines, and we're going to look into automation accounts, log analytics, and metrics and alerts, okay? So the first thing we'll need to do before we do anything else is make sure that we have particular resource providers enabled. So go to the top here, and as always, go to your subscriptions, and we will click into our subscription, go all the way down to the bottom, click on resource providers. And there's two in particular we're looking for. One is for alerts, so it's alerts management. So make sure that is registered. If it's not, press that button. And then we want insights. So make sure insights is enabled as well. They should be by default, but just in case they're not, you should go ahead and do that. So we are going to need some virtual machines. I'm going to set up 3. And the reason I want to do that is just to show you that there's many different ways in Azure to do the exact same thing. And sometimes when you do something, it just works. And sometimes it just doesn't. And it can work again and not again. So I want to give you a few different options available to you. So the first thing we're going to spin up is a virtual machine. And this one in particular, we'll make a new group. And we're going to call it DAX. And so we're going to choose for this one an Ubuntu Linux. I'm going to switch it over. I'm going to choose a minimal install. So we'll choose this one over here, which is the Ubuntu Server Minimal. And what I'll do is name this. And there's a bunch of different DAXs in Star Trek. So we're going to go with Curzon DAX here. And we'll put all this in East US, so wherever it defaults here. So if that's where it wants to go, that's where it's going to be. But let's pay attention to where that is, okay? Let's make sure that we're using a very inexpensive instance. We'll give it a second to load. If you do not see the cost, just drag these over until you do. It just depends on your screen, right? So once this loads, it will tell us that this is probably the cheapest. I think that is the cheapest because nothing's going to go lower than at 500 megabytes of RAM. So I think we're already set to it. I'm not going to wait for that to load. It'll take forever. Notice the red line. There is no error. That's just what it shows. And so I'm going to go for password authentication here. And what I'm going to do for this account is I'm going to type in DAX as the username and then testing with a capital TESTING 1 2 3 4 5 6 because it wants an uppercase, a lowercase, some numbers and a certain length. And that's what works for me. So now that I have those filled in, SSH, we're going to keep that open. We're going to go to disk. You can leave it on premium if you want. I'm going to go to standard. I want to save some money just in case I forget to turn this machine off. It's going to set up some networking for us, which is totally fine. We're going to go to management. And I believe, so there should be guest OS install here. It is not here. It's the next step, I believe. Where is it? I know you're in here. Let's go back one step here. I have a feeling it's on this page because you can install the guest OS metrics right away. So I'm just seeing here. I cannot seem to remember where it is. I might have skipped over it because I'm going so quick here. Well, maybe it's not set here. So when we go to do the other virtual machine, we'll see if it's actually there. But for this one, we'll just launch it without it, which is totally fine. I was going to do one that way anyway. And so we'll go ahead there and create that virtual machine. Okay, now while that is going, and by the way, if you think you call that number, that's not me. So, you know, you can call it if you want, but it won't go to me. So that's going to go ahead and deploy that. What I'm going to do now is go and launch another virtual machine in the same environment. So this one, this time around, is going to be, again, it's going to be Linux. We're going to choose DAX here. And this one is going to be Jadzia DAX. And we, this time around, are going to choose Ubuntu Server LTS. So this one's a minimal install, and this one here has a bit more to it. We're going to choose Gen 2. This is now $4.86, which is strange. It looks like it was the same one before. I don't know why the other one was so more expensive. I could have swore it said $40, but maybe I was mistaken. The red means nothing as per usual. It's just Azure tricking us. We're going to call the username here DAX, testing with a capital TESTING. You know what I'm trying to say here. And I'm going to do testing 1, 2, 3, 4, 5, 6. And we will go next to disks. We'll stick with premium for this time. It doesn't really matter. If we go to advanced here, there's no interesting options there. This is all fine. This looks good. We go to management. So now notice here, so we didn't have it for the minimal install, but for this one we do. We can actually put in the guest OS diagnostics, and what it will do is it will have to create itself a storage account. So that will be in Azure Storage to store our diagnostic data. And so that seems like a good idea to me. So what we'll do is we're going to go to next. But notice we didn't have it for the minimal install, probably because it doesn't have the agent, what's called the WAG agent installed for it to do that by default. So just notice that it varies on some machines. We're going to go to next. We're going to hit review and create. And we're not done yet. We're going to create one more virtual machine, and this time it's going to be a Windows. Once I hit the create button here, we're going to go back to virtual machines, and this time I'm going to launch a Windows machine, and I'm going to use, we're going to put in the same group here. I'm going to call this one Tobin, or let's call it Leela Dax here. And this time I'm going to choose a Windows server. So I'm going to go to Windows Server here. We have a lot of options. I'm not that great with Windows servers. I'm going to choose a Gen 2 Windows server here. It's not going to let us get away with this B1L. It's not big enough. You need a lot more compute and memory. I think it's like 2 and 4. But I just remember to always choose DS2 V2, which is pretty hefty. It's pretty expensive. Maybe I could choose something cheaper, like the DS1. No, I need two CPUs. So DS2 V3, that's when you're launching a Windows server. If you don't do that, they'll complain. And that will probably be pretty darn expensive, but we got to make sure that we just shut this off and get through this as quick as possible. I'm going to choose the same thing as always. So I'm going to put in DAX. And then for the password, I'm going to do testing 123, capital on that T, 456. Testing 1, 2, 3, 4, 5, 6, because it wants 12 characters. We're going to let it do on the RDP. That's totally fine. Sure, premium SSD. We're not going to keep this around for very long. We're going to scroll on down, go to management, and notice that you can enable OS diagnostics here. I'm not going to do that here, just so I can show you it in the other variation. We're going to go to next. We're going to go hit review and create, and we're going to go ahead and create this instance whenever it lets us do it. There we go. Okay, we'll hit create. And now it's deploying. So we have these 3 virtual machines we're creating. And so what I'm going to do is make my way back to virtual machines here. And so I have the 2 there. I'm going to give it a refresh, make sure I can see the 3rd one creating. We don't see it just yet, but these ones are running. So what I'm going to do is open up Curzon. I'm going to open up Jedzia. And one has the guest the guest or the, what's it called, diagnostic settings. It's the guest metrics installed, and the other one does not. So if I scroll down here, so I just want to show you there's a lot of variation, and sometimes you do it one way, it works, another way it doesn't. So for Jedzia, it was installed on default, so that's the one that is using Ubuntu standard. And then this is the minimal install, where it's saying, hey, do you want to install the metrics? And you have to pick a storage account. If you didn't, then you would have the option to create one. Here it's called DAX DIAG. So I just want to show you, we're going to go ahead and enable those guest level monitoring metrics. Okay. So we have a storage account, and that's where the data is going to go. And this will probably fail because I don't think it has the necessary things installed, but I just wanted to show you could do it that way. But another thing we're going to need is we're going to need a log analytics workspace. So all a log analytics workspace is a place to store your logs. It is essentially a data lake for a lot of different resources. So you can put all sorts of resources under here, and that way you can search across them, see how this failed. If you ever have a failure like this, the way you'd investigate this is you go in here, and even though it says a SAS token for the storage account couldn't generate, it's kind of a misleading thing here, because if I actually click up into my notifications, we go to our activity log, we can see kind of what something has happened here. So I know this failed. It might have not show up here yet. Sometimes it takes time to show up. So we'll revisit this later, but it would show red errors here. And if we looked into there, it would tell us that Python's not installed on that machine because it's a minimal Linux install. So if you run into those problems, that's the reason why. Some VMs are a bit easier to work with than others. But we're looking at log analytics. And again, it's just a place to collect your logs. But I want to see because I think Jitsi is the one that actually is the one that is working properly. But if we go down to metrics or logs, it's going to say, hey, if you want to use logs, you're going to have to go ahead and create, you have to enable it. But what it's really doing is just creating a log analytics workspace. So if I click this here, what's going to tell me is say, hey, you don't have one, we'll create a default one for you. I don't want to do it that way. What I want to do is create one myself and then link it through there. Or what I could do is make it through automation. So what I'm going to do is, I think what I'm going to do is I'm going to do through automation. So there's another service called automation accounts. And this particular service is for configuration management, update management. And it's a way for us to keep our VMs up to date. And so this one's going to be called DAX. Oh, it's too short, doesn't like that. DAX automation. And I'm going to choose the resource group DAX. It's East US. And here it's going to say Azure run as account. So this is going to give it more permissions so that it can run as a contributor role. And that way it will have access to resources to do what it wants to do. So we'll go ahead and deploy that. And then once this is deployed, we'll create our workspace through this. Because I found an issue where if I made this and tried to link it, it just didn't link. And I don't want to have those problems. So I'm just going to make my life a little bit easier by making it through here. So under here, if we go to update management, it's going to say, hey, you need a workspace in order to use update management. If you're wondering what update management is, it keeps your VMs up to date by applying patches. So if we drop down here, we're just going to go ahead and create a new workspace. And I'm going to do it that way, because then it'll be automatically associated with that workspace on creation. And we'll let that go there for a bit. But while that's setting up a new workspace for us, if you go over to Runbooks, this is the power of, oh, I'm not, it wants to make that thing there. So I'm just going to click OK there. Don't worry about that discard. But the whole power of this is that it can apply patches. It can manage the state of your VMs. But if you need to do something, like run something like a series of run commands, they have a bunch of different run books here. So there's a variety of different kinds, and I think we can click into them. There was something about SQL that sounded kind of how to use an SQL command on a automation run book. So yeah, it's just a run book. So run book just means like a series of run commands, something that you're automating on your server, and you do it through here. So update management looks like it is now working. We didn't press that enable button initially, but it worked there. But if we wanted to have VMs under here, we'd have to go ahead and add them manually. And so we're just going to wait for those to show up. Alternatively, if we go back to our server, or sorry, one of our VMs, we should be able to add it this way, or it'll just tell us to go that way anyway. So there should be like update management or something in here. Could be configuration management. Yeah, that still would be through something, right? So it'd probably be still through automation. But I could have swore there was, maybe it's guest and host updates. Yeah, so here it's just saying go to Azure Automation. So you don't really set it through here. You have to associate it through Azure Automation. And so these are ready to enable. So I'm going to say go ahead and enable those. I don't know where our Windows server is. We definitely spun one up. It's not a big deal if we don't have it. It's not really crucial to this tutorial, but it would have been nice to show the Windows 10 there. I'm going to go see what happened to our Windows server. Oh, it is there. Okay, Leela's there. So we'll take a look at that in a second. But we're just adding those there. We're not going to really apply any patches. I just want to show you how to associate them there, and just to highlight the fact that there are run books, which are pretty cool. And you can also do other things, like if you need to like install Python packages or stuff like that to do stuff, you could do that as well. So there's a bunch of interesting things in there, but it's kind of like a side dish to the follow along here. So this would have created our workspace. So now let's go over to our workspaces. And we have one here. And if you're just curious what it looks like, if we go here, there's nothing super exciting. You just put the name and region in, and it has the default pay as you go. So you're not really missing out on creating one by hand there. But underneath here, what we can do is see if our virtual machines are actually associated with this here. So if we go under virtual machine, you're going to see that these ones are connecting, which is interesting because I didn't do anything to connect them. I'm not sure why that's happening, but I'm going to hit connect here. And that will connect that. A lot of times I'll come in here, I have to manually connect them. I don't know if it's because we put them in the what do you call it, within the automation there. If we go back to automation, which ones did I choose? I already forgot. Update management. Well, they're not showing up here now, but I know they're there. Maybe we triggered it when we were doing there. But anyway, the point is that you have to make sure that those are configured so that it's actually sending data over to the workspaces so that we can then use the logs and things like that. So if we go back to our virtual machines over here, you can see they're connecting. This takes forever. While this is going, let's go take a look at storage accounts. And actually, a better way would just be to go look at the virtual machine individually here. So we'll just go back to my virtual machines, and I go to the resource group. We scroll on down here. We should see a storage account within here. Let's just type in storage. There it is. Whoops. And the thing is that we can actually view some of the data in here. So if you go to Open Explorer, you'd have to install this. It's for Windows. I think it's for Mac as well. But once you have the Storage Explorer open, you can just click Open here. And it'll open up once it's installed on your computer, of course. And what I can do, if we have any data, it might not be collecting any data yet, but if we go down to our storage accounts here, oh, here it is down below, and expand it under tables. So you have this WAD, that is the name of the agent that is collecting data. And here you can see that it's already collecting stuff. All right. And it's collecting for Jadzia DAX. And so I'm just kind of looking at the data that's collecting, nothing super interesting. But the thing is that we're going to make our way over to logs because by default, Azure collects host metrics, so things about the instance like CPU usage, but there's things that it doesn't collect like memory and other things like that. So that's why we need to turn on this setting here, the diagnostic settings, so we can collect those metrics. These are called guest metrics. So we have memory, network, file disk, and storage. So if you wanted to know how much storage was left on the actual disk with the virtual machine, or how much memory was being used, you'd need that set up here. Once this is enabled, you can send data over into Azure Monitor and other places. It's not showing App Analytics. I think that's for, or Log Insight, whatever the name of the service is. It's for that one. I think it's for the Windows one, so we'll see that when we go over there. But Syncs just means we're going to send data from here to Azure Monitor, right? But we'd have to have preview to see that. Nothing that interesting here. But if we go over to logs now, this should not be showing up here anymore. So if this is still showing an enable screen, then we got to go back to our log analytics. We'll click into here. We'll go down to virtual machines and we'll see if it's connected yet. So it still says it's connecting, right? This one's ready though. And I haven't even done anything with that one yet. So what we'll do while we're waiting for these Linux ones to spin up, we'll go back over here to our virtual machines, and we'll go find that Windows machine, which I don't know why it's not showing up here. There it is. And what we'll do is we'll go ahead and connect to it. So I am on a Windows machine, so I'm going to shape here, and I'm going to click on RDP, and I'm going to download that file. I'm going to double click this file on my Windows machine, and I'll be able to open this up instantly. It was called DAX testing 1, 2, 3. Whoops. Testing 1, 2, 3, 4, 5, 6. Looks good to me. We'll hit OK. We'll say yes. Because if you want to collect particular metrics, the guest metrics, you have to enable, like when you're on Windows Server, you have to enable it to send performance counters. So I'll give it a moment here. It doesn't take too long. While that's going, we should look to see if we actually have the settings set up here, the diagnostic settings. And so this is what I'm talking about, the enable guest level monitoring. So we want CPU utilization, disk, and network. So we'll go ahead and click that there. And while that's going, and go back here. And so this has now started up. I don't know much about Windows servers, but I do know how to turn on At least the last time I did, I know how to turn on the performance counter. So see here, it says online performance counters are not started. So I can right click this and then just say start performance counters. And that will have it start sending data over to our storage accounts, assuming that this is enabled here. So this is going to go ahead and install WAG into the Windows server so it can send back metrics. And so we got a lot of things going on here, but let's go back to Jadzia. And I want to see now if I can use logs now. There we go. So it's now connected to the workspace, so it knows where to send that data. And you can pull up, when you go to logs, it'll show different types of default queries. If you're in the actual group here, you'll have the same screen, but it'll show you across all possible resources. So it's a little bit easier to figure out like useful queries for virtual machines when you do it through here. And there's some that we can run right away. So if we go over to the diagnostics, we could, or actually availability is a good example. So heartbeats will tell you if the server is live. So a server will have heartbeats. So every whatever second or minute, it's going to say, hey, I'm still alive. That's what a heartbeat is. So we'll go ahead and run that. And we'll give it a moment here. I'm not sure why it's crying. If that doesn't work, I'll just click off and try that again. So go back to availability, we'll hit run. And it has the right scope. If you're wondering how it knows what to check, that's all based on scope there. And for whatever reason, it just decides that it doesn't really want to run right now. That's a bit frustrating. But if it's not working for this one, we can always check our other one, which is Curzon. And we can go see if this one works. That's why I made multiple servers, because I knew one of these might not work right away. So we'll go ahead and run this one here. It says no logs are configured. So that makes me think that our workspace here, if we go back over to here and we go down to virtual machines, that they're actually not linked. Oh, they still are connecting. There you go. So it's a bit misleading. It looked like we could query, but we still can't. Let's go take a look at this virtual machine here, our Lila one still. And let's see if we can do anything with it yet. So if we go down to diagnostic settings, it looks like it's installed. And so if we go to performance counters, these are the counters that it should be collecting data on. You could do custom if you want and change those values, but we're just going to leave it basic for the time being. Go ahead and save that. And I believe we can do logs over here on this one. So we'll go over to availability. I'm going to load that into the editor this time instead of hitting run. And I can hit run, and it will return and says that it has a count of 7. So 7 heartbeats, that's good. If you wanted to create rules, you could easily do that. There's actually some nice ones here. If we go into here, this won't work unless our metrics are working, our guest metrics. But there's a bunch down below here. I'm just trying to see one that might be interesting for us to set. So you might go here, and I don't think I like that one. Say this one here. I'm just going to clear this all the way out. Oops. So here they even say to create this alert, just hit the plus new button here. So we can go here. And sometimes it does this. It doesn't actually bring it over, which is weird. So you have to go back. I told you, like this, the UI for Azure is super, super buggy. So if you don't have any confidence, don't worry. It happens to all of us. So we'll go back to our alerts. And I'm going to load that into the editor. And what I'm going to do is just copy it. And we're going to go ahead and hit run. And so here we're getting some data back. I think it's going to complain about the time generated. But if we go and create a new alert, oh man, it just does not want to copy anything over, eh? And so I can't even paste. We'll go back to here. I'm going to copy this. I noticed it was because I had it double clicked. Maybe it just creates one what you have selected. And so it should complain about this, but it's not, so that's great. And so we can go here and we can put a threshold to 5. I'm just putting any value here, and that gives you a monthly cost for that alert. So you can hit review and create. Please correct the following details. Where? Oh, the alert name. Okay. My alert. And we will hit review and create. We'll hit create. And so there we can create an alert. So we could create an alert like our memory's running out of stuff. And those are kind of useful things to do. So talking about metrics, we're going to make our way over here. And notice we have host metrics and guest metrics. So host metrics are general ones that are available to us, and guest metrics are memory and stuff like that. So if we have that, you're going to notice now we have like disk and memory and things like that. If we didn't have that installed, we wouldn't be able to access this information. So what I can do is go ahead here and try disk time. I don't know if it'll show us anything right now because it might have not collected enough information. We go over to virtual host. We'll have different metrics here. So a standard one would be like CPU usage. Okay, so that one is displaying there. The poor performance metrics always take a little bit more time to collect, so I'm not sure if I'll stick around to show you that, but if we go over to availability, sometimes when you need to go debug performance, like you can hit run, and this will tell you if it's actually collecting information. So C right now, it shows me nothing, so it hasn't collected anything for process, memory, or processor. But if it did, then we could go and use these other ones down below here. So we have free disk space, so that's a really useful one to have, which we can't get metrics on that right now. But that's what we've been trying to do, is collect that information. So let's go back to our workspace. And what I'm going to do is take a look at our virtual machines that are connected. And this one has an error, and that's Curzon. And I'm not surprised because, again, it's a minimal Windows Linux instance, so probably couldn't install the agent. So that's expected, but I just wanted to show you that edge case. If we go into the Jadzia one, which is the one we were waiting for this entire time, we should hopefully be able to see some metrics. So if we go down here and we choose guest metrics, I want something with memory here, like percentage. Okay, so it's still not showing me anything, and that's fine. If we're not getting any metrics, what we can do is we can go log into this instance and give it some data so that it does something, all right? So what I'll do is go all the way to up the top here into my overview. I'm going to copy this public IP address. We're going to open up our Cloud Shell, make sure that it's in bash, all right? And we're going to type in SSH DAX. And then we're going to paste the IP address in. We'll hit enter. We'll say yes. And the password is testing1234556 with a capital T. And what we can do here is we can install a tool called StressNG. What that tool does is it will help us do stress testing. And so that allows us to make some metrics. So we'll go ahead and install that via Snap. Snap is the new package manager for Ubuntu. It used to be apt-get or apt. And it doesn't take too long to install. And while it's installing, I actually have a pre-made line here to check the memory or to fill up the memory. I'm just going to go ahead and paste this line in. So this is stress-ng VM bytes, and it uses awk, and it's going to do memory availability, and it's going to fill it up to 90%. So we want to have 90% memory usage. I'm going to go hit enter. I'm just going to let that run. Now it's not outputting anything, but it definitely is running. There we go. And so we're just going to leave it there. And so soon enough, we should have some information. And I think if I go there, yep, it's still there, so it's fine. So now if we go over to down to our logs, and we go back to performance, and we just choose this one here, we might see something now. Again, it takes time. See, now it looks in the 15-minute window here. But I just want to see that it's collecting anything. For me, it doesn't matter what it collects, just collects something for me, you know? So I think it'll just take a little bit of time. While we're doing that, we should make our way back over to our workspace because there's some other settings that are kind of interesting that I noticed. If you go over to agent configuration, you can collect additional information over here. So we have performance counters for Windows and Linux. I think we have to set the memory one here if we want it to actually appear here. So I don't know if there's a way to set all of them, but I'm going to just choose some here. So I'm going to do memory used. We'll do logical use space here. We'll go here and do free space. I think that might be the reason why it's not showing up for us. Maybe process time here. We did use memory, use percentage of use space. We will do reads and writes. So here we have some for our Linux. So I think if we set that, then we should be able to see some information. Syslogs is just a type of logs that you can collect. We're not going to look into those today. But yeah, that's the management there. We could also try setting some here, maybe one for memory. I can't remember what the one for memory is called here because they do all of this kind of stuff. Like Windows has so much stuff, I can't make sense of it. I think we might want paged owls and page, so the one called there. Bytes, we'll give that a go. And we'll see if that starts collecting information. I'm going to go back over to here. And, oh, this is Curzon. That's the Windows machine. We're going to go to the Linux machine here, and we'll give it another go. See if we get anything this time around. So we'll go back to performance. We'll say what is being collected, run. Okay. And so I think we're just going to have to wait a little bit. So I'm just going to stop the video here, and I'll see you back in maybe 15, 20 minutes, okay? All right, so I'm still waiting here, and I don't seem to be seeing any data, but that's okay because there's another way we can kind of approximate this, and we don't have to wait forever, especially if you don't have a lot of time like me. The thing is that Azure has a log analytics tutorial, and within here, they have a demo environment that I'm very familiar with. And so this can approximate exactly what I'm trying to show you here. If you notice at the top here, it says Microsoft Azure monitoring logs, demo, log, blade. So if we go to queries and we go down to virtual machines and we look at what data is being collected, we can hit run here. And this is the kind of information we are trying to see, right? This is what we want to see, what it's actually collecting. That's okay. We're not doing remote desktop anymore here. And if we go to virtual memory available, we'll just clear that out there and run that. This is kind of the information we're trying to find. All right. So I just wanted to show you that when you collect those metrics that you can run these queries, and this is that language up there with Kusto. And that's pretty much it. That's all I really wanted to show you. So let's go ahead and tear down all our stuff. It's all self-contained within a resource group. So what we can do is go to all resources in the top left corner there. And we called it DAX. So we can search for DAX here. Whoops. Actually, it's all over the place. We just click here into the name. And we'll hit delete resource group. Type in DAX. We have a lot of resources created for this one. And there you go. So yeah, hopefully that helps you understand those relationships between automation accounts where we can run runbooks, do patching, stuff like that, install Python stuff. The fact that log analytics is basically a data lake for all your data, that you can create alerts, that you have metrics, you have guest OS metrics, which collect those three values, the memory, the network, and the additional CPU information or disk space, and just the variance there so you don't get stuck. So there you go. Hey, this is Andrew Brown from Exam Pro, and this fall long we're going to learn about managed identities or system managed identities so that we don't have to pass credentials or hard code them into our virtual machines or other environments. So what we're going to do is launch ourselves a new virtual machine. This is going to be a Windows server, so go ahead and hit create. We'll create a new virtual machine. And from here we'll say create new, and I say my managed identity, or I'll just say ID so I don't have to spell the whole word. And we'll just say my managed ID. And from here, Central US is fine, the zones are fine, but we're not going to use Ubuntu. We're going to hit see all images. And from here, we will choose Windows 10. There's a lot of options here. So I want Windows 10 Pro. It's a bit hard to decide, so I'll go Gen 2 21H2. Hopefully, you'll be okay doing this as well. It's using standard B2S 46, so just make sure you're not overspending, so that should be fine. I think we need at least a B2S to run this, but we're not going to keep it around for very long. For the username, I'm going to go admin user, and for the password, capital T, testing 1, 2, 3, 4, 5, 6. I'm going to do that again. Capital T, testing 1, 2, 3, 4, 5, 6, exclamation mark, just because of the requirements. It's such a pain. That's what I always do in these follow-alongs. And we're going to use RDP to connect to it because we do have to remote into it. We'll just say I confirm. We'll hit review create. Of course, we don't actually have a license, but we'll be okay because we're not doing anything too serious. And we'll give it a moment here. And we'll hit create. So that is going to create. While that is going, I'm going to, well, actually, we have to wait a little bit. But we'll make our way over to the resource group because this is where we're going to be adding an IAM policy at some point. So if we go over to IAM over here, and we'll actually wait for this to provision. So this takes quite a few minutes. So I'll see you back in maybe 5-10 minutes because we are launching a Windows server. They just take longer. So after waiting, 5 to 10 minutes, the environment is ready. So we'll go ahead and go to that resource, and we're going to want to go connect and choose RDP. This is going to be Remote Desktop Protocol. I believe that's what it stands for. If it doesn't, not a big deal. Just know it's called RDP. And so we'll have an RDP file. We'll double click it. We'll hit connect. This is going to open up the remote desktop client. And so we will type in admin user and then capital T testing 1, 2, 3, 4, 5, 6. If you're on a Mac, you're like, how do I do this? Well, it is in the Mac store. Just type in remote desktop. Hit open here. I'll just show you what I mean. Over here, we do RDP Mac. You can see that it's free to download. So it's just you download that and you can open those RDP files. So we are just waiting for this to spin up. This takes a little bit of time, so just give it a few minutes. All right, so after waiting a little while, the environment is ready. So hopefully you can see what is going on here. And so what we want to do is open up PowerShell. So we'll type in PowerShell here, and we will right-click and run as administrator. This does have an outbound connection to the internet, so I know that we are okay for our connection. And then this is where we will need to install Azure modules because it's not pre-installed, and this part really sucks because we have to wait a lot more again. So I hope you like waiting a lot. But anyway, what we'll do is right-click this properties here, and we will bump this up because this font is super, super small. And we will type in install module AZ, and that will install all the commandlets for Azure, and we'll wait for some prompts. The prompts are a bit finicky. Hopefully we can just do A for all, but you might have to hit yes a couple times. But this part is just so slow. There we go. So notice it doesn't let me say all. We'll just say Y. And I know that it's going to prompt us again, so we'll just wait a little bit here. The progress will show up at the top. It's kind of glitchy. Yeah, so now we'll do A for all. And so now we just wait a long time. Now it seems like it's not doing anything, but you will eventually see something appear up at the top here that shows you that there's progress, but you just have to be very patient. Yeah, so it'll look like that. I'm just showing you what it looks like, and I'm going to go back and pause till this is all done because it takes forever. All right, so I think it's done. It's sometimes hard to tell because it'll just kind of like blank out here. And it's not doing anything, so I'm not 100% sure. But what I'm going to do, I'm going to see if I can just open it twice. This is just the PowerShell experience, right? And To test this, we'll just do a connect and see if it works. So I'm going to do connect. I just don't want to close the old one if it's actually still doing something. Connect account, identity. And so if this prompts us with something, then we know that it's working correctly. So identity not found. And that's fine. So the thing is, if we just did this, it would actually prompt us to log in. So see, it's prompting us to log in with Microsoft. So this worked. But we need to actually connect an identity to this virtual machine. So that's what we're going to do. So we'll minimize this. We'll go back over here. So go into your the resource group that we had before under IAM, and we're going to add a new role assignment. And from here, we will choose contributor because that will give us enough access for stuff. We'll choose manage identity, and we will choose system identity. No, that's not what I want, because it should show the virtual machine here. Maybe it's because we opened this before it was done creating, so that's why it's not showing up. So we'll try this one more time. We'll go to contributor because it should show the virtual machine, managed identity, select. And I want to see the virtual machine. Weird. So I'll click way out. I'll go back in. I'll go to IAM again. We'll go to, oh, you know what? We launched this virtual machine. We forgot to checkbox something. So when you launch the virtual machine, you're supposed to checkbox manage system identities here. So this would be, where would it be? I only ever do it through the setup. I never ever have to retroactively do it. Oh, what a pain. Identity maybe? System manage. So we'll just say on and we'll save it. Grant permissions. Do you want to enable a system managed entity? Yes. But normally when you do the virtual machine, hold on here. We'll just go pretend like we're setting up a new one. We're not actually going to set one up, but when you are setting it up, and we go over to advanced, management, we would checkbox it on here. But that's not what we did. So we forgot to do that, but we turned it on here. So hopefully it works without us having to restart the image. If we go to role assignments over here, I mean, that's just another way of getting to this page. So it doesn't really matter for the resource group. What we'll do is go back to our resource group. We will find it here, and we will go to IAM, and we will add a role assignment, and we will add contributor. We will go next. We will say manage identity. We will select. We will go to virtual machine. We will select this one. We'll hit select. We'll review and assign. We'll review and assign. And then it will assign us contributor access. So now we should be able to connect our identity and then also get access to some stuff. Because what we really want is to do get AZ, like to just show that we can get anything. Because right now if we do this, get AZ subscription, we're not connected in any way. So we'll go here and we'll do identity. Fingers crossed it just works. Yes, it does. That was nice that we didn't have to restart the machine. And so now if we do get AZ subscription, it should work. So I don't see it working. Did I type it wrong? The term is not recognized. Oh, I must have typed it wrong. Subscription here. Let's get the subscription. So if we were not authenticated, that would not work. And so it does work now. So we are pretty much all done here. Well, we could probably list out some resources just to make sure this is working properly. So maybe go get AZ resource like that. There. So list some resources, and it's only listing what's in the resource group because that's all it has permissions to. It's not going to show things outside of that because that's the scope when we did it at the resource group, and that's why we went at the IAM level there. So we are all done. We will go ahead and close this out. Okay. We will make our way back to our resource group. We're already on it. We'll go ahead and delete this resource group. Say delete. And there you go. Hey, Hey, this is Andrew Brown from Exam Pro, and we are looking at virtual machines for Azure cheat sheet. So let's jump into it. So Azure Virtual Machines allows you to create Linux and Windows virtual machines. The size of the virtual machine is determined by the image. The image defines the combination of vPCUs, memory, storage capacity. The current limit on a prescription is 20 VMs per region. VMs are billed at an hourly rate. A single instance VM has an availability of 99.9% when all storage disks are premium. 2 instances deployed into availability set will give you 95% availability. You can attach multiple managed disks to an Azure VM. When you launch an Azure virtual machine, other networking components will be either created or associated to your virtual machine, such as NSGs, interface cards, IPs, and VNet. You can bring your own Linux by creating your own virtual hard disk. Azure VM comes with a variety of sizes that are also optimized for specific use cases, and there's a lot of different ones here. So it's not super important, but I mean, you should know the broad categories here. Azure Compute Unit, ACU, provides a way of comparing CPU performance across Azure SKUs, and the standard one that the one they're all benchmarked against is standard A1. All other SKUs then represent approximately how faster the SKU can run on the standard benchmark. You can install the Azure mobile app so you can monitor your VMs on the go. Hyper-V is Microsoft's hardware virtualization product. It lets you create and run software versions of a computer called virtual machines. That's how it all works. There are two generations of Hyper-VM. You got Generation 1, which works with most operating systems, and Generation 2 that supports most 64-bit versions of Windows and current versions of Linux and FreeBSD operating systems. Hyper-V VMs are packaged into virtual hard disk formats such as VHD, VHDX files. Not on the exam, but just understand that Hyper-VM generations are different from the Azure Hyper-VM generations. So it doesn't have all the features of Hyper-VM, okay? There are 3 ways to connect to virtual machines. The first is via secure shell. It's not sure shell, it's secure shell. Yeah, so that'll have to get fixed at some point. SSH happens on port 22, and RSA key pairs are commonly used for authorized access. Then you have RDP, which is a graphical interface to connect to another computer over the network connection. This is how you can remotely connect to the Windows Server via virtual desktop. This happens on port 3389 on TCP and UDP. Now, I mark these red because I want you to remember these two, so make sure you know them, okay? Azure Bastions, and we'll clear that because now it's getting a bit of a mess here. There we go. So Azure Bastion, a service you can deploy, lets you connect to a virtual machine using your browser and Azure portal, supports both SSH and RDP, useful when you only have a browser like a Chromebook or do not have permission to configure or install software. Then you have update management. This allows you to manage and install operating system updates and patches for both Windows and Linux virtual machines that are deployed in Azure on-premise or in other cloud providers. Update management will perform a scan or update compliance. A compliance scan by default is performed every 12 hours on a Windows and 3 hours on a Linux machine. It can take between 30 minutes and 6 hours for the dashboard to display updated data from the managed computer. So there you go. That is the virtual machines cheat sheet. So let's take a look at ARM templates, and before we jump into it, let's just make sure we're familiar with infrastructure as code, because that's what ARM templates are all about. And this is the process of managing and provisioning computer-centered data centers, such as Azure, through machine-readable definition files, such as a JSON file, and in this case, an ARM template, because that's all it is, a JSON file. And rather than physical hardware configuration or interactive configuration tools. And just to simplify that even further, basically you're writing a script that's going to set up your cloud services for you. And with IACs, they usually come in 2 different flavors. We have declarative. That's where exactly what you write is what you get. And imperative. So you're going to generally define what you want, and then the service will guess what you want. It's going to fill in the blanks to save you a lot of time writing those scripts. And so ARM templates are JSON files that define Azure resources that you want to provision and Azure services that you want to configure. And with ARM templates, they are going to be declarative, so you get exactly what you define. They're going to stand up, tear down, or share entire architectures in minutes, and they're going to reduce configuration mistakes. And you know exactly what you have defined for a stack to establish an architectural baseline for compliance. So you definitely want to use ARM templates or IAC whenever you can, and try to avoid using the console unless you're doing development or test workloads. But let's just run through the big list of what you can do with an ARM template. I know this is a big boring list, but let's just get through it as quickly as possible, just so we know what we can do with ARM templates. So with ARM templates that are declarative, so what you see is what you get. You can stand up, tear down, share entire environments in minutes. You can reduce configuration mistakes. You can establish an architectural baseline for compliance. They're modular, so you can break up your architecture in multiple files and reuse them. They're extendable, so you can add PowerShell and Bash scripts to your templates. It has testing, so you can use the ARM TTK to test, make sure exactly what you've deployed is what you wanted. You have preview changes, so before you create infrastructure via templates, you see what it will create. Built-in validation, so it will only deploy your template if it passes. Track deployments, keep track of changes to your architecture over time. Policy as code, so apply Azure policies to ensure you remain compliant. And then you have Microsoft Blueprints, which we did cover here, which establishes relationships between resources and templates. So it's just one step further, where ARM templates don't have any relationship with the resources, where Blueprints is like a better version of ARM templates. And then you have CI/CD integration, exportable code, so exporting the current state of the resource groups and resources. Authoring tools, I believe, is the last on our list here. So you can use Visual Studio Code that has advanced features for authoring ARM templates. Makes it a lot easier to write them. So there you go. So now we were talking about what ARM templates can do. Let's actually take a look at what one looks like. And so just to get a good snapshot or overview, let's just define what the skeleton is, the general structure of an ARM template. So here on the right-hand side, we have JSON, and you can see that we have a structure there. So we have schema, content version, API profile, parameters, variables, functions, resources, outputs. And let's go down the list here and see what all these things are. So the schema describes the properties that are available within a template. And so the idea is that you have that JSON link there, and it's going to say, we expect the schema, the actual structure, to have these parameters. Then you have the content version. This is the version of the template, and you can provide any value for this element. It's totally abstract. It's just your way of keeping track of the version of your current template. Then you have the API profile. You use this value to avoid having to specify API versions for each resource in the template. You have parameters. These are values you can pass along to your template. You have variables. This is where you transform your parameters or resource properties using function expressions. You have functions. These are user-defined functions available within the template. You have resources. These are the Azure resources you want to deploy or update. And then you have outputs, and these are the values that are returned after deployment. So let's go more deep into some of these things. So let's take a deeper look here at the resource section within your ARM template. And so a resource is an Azure resource you want to provision. Could be a virtual machine, could be a database. And so here on the right-hand side, look at where it says resources, and we're going to take a breakdown of the actual columns or attributes that we can set. So the first thing is the type, and this is going to follow the format of the resource provider and resource type. So there you can see that we are setting up a storage account. Then we have the API version, and this is the version of REST API that we're going to use for that resource. And each resource provider publishes its own API version, so you got to go look up each one because they all could be different. Then you have the name of the resource, and so I believe there that is using a variable, so that is going to be dynamic. Then you have the location, so most resources have a location property, and that's the region that you want it to be deployed in. Then you have other properties, and other properties will be based on different kinds of resources. So for a storage account, you want to be able to set the kind, and within the properties, you're going to have a bunch of other options there, and it's just going to vary, okay? But anyway, let's take a closer look next at parameters. So let's take a closer look here at parameters, and these allow you to pass variables to your ARM template. So on the right-hand side, we have our ARM template, and we saw before resources, but if you look above there, we have a thing called parameters, and so there we are setting a parameter, and then down below in the resource, we are accessing a parameter. And so let's just actually talk about some of the parameter options we have. So the first thing you'll want to do is set a type. And on the right-hand side, you can see that we're saying it as a string. And so we could define that as a string, secure string, int, bool, object, secure object, and array. And there are some other things that we can provide when we are defining our parameters that we're not showing in that diagram, but we have default values. So this is if you do not provide, if there's no value being passed in, this is what it should use. Then you have allowed values. So this is where it's an array and you're restricting it to only the values that are there. Then you have the min value. So if let's say it's an integer, you want to say this is the minimum value. So it can only, like, nothing lower than 10. Then you have the max value. So nothing above 10. You have the minimum length. So if you're working with strings, you might say it has to be a minimum of 5 characters. Then you have the maximum. So let's say you have a maximum of 5 characters. Then you have the description. So this is just going to be something that when you are using the ARM template within the portal, you know what it's for. So if you don't have a great description for that parameter or name, and you want to provide more information, that's what you can do. So there you go. So let's take a look here at functions for ARM templates, and these allow you to apply transformations to your ARM variables, and they come in 2 flavors. We have template functions, which are built-in functions, and then user-defined functions, which are custom functions that we're creating to allow what other kind of functionality that we want. So the way functions work is you give the function name, so here it's called equals, and then you have parentheses and you pass in what you want to transform. So if you see parentheses, that's how you know that is a function. So let's talk about some of the built-in functions. And so there are a lot available for us, and they're generally self-explanatory, so I'm not going to be showing examples, but let's just go quickly through the list. So you have array functions like array, concat, contains, create array, empty, first, etc. Then you have comparisons like coalesce, equals, less, lesser equals, greater, greater, or equals. You have date functions. You have deployment functions, and for example, parameters and variables are actually functions. So that's kind of interesting. Then you have a logical operators, so and, or, if, not, or. Numerical functions like add, div, float, int, min, max. Objects, so contains, empty, intersection. And then you have resources, so extension resource ID, providers, references, etc. like that. And there's one more. I think we have strings. So we have base64, concat, contains, etc. I'm not going to show you how to do user-defined functions. I don't think that's that important. But I just want to show you that you have a lot of functions available to you, okay? So let's take a look at variables, and variables are used to simplify your ARM templates, and the idea is that you're transforming parameter and resource properties using functions and then assigning them to reusable variables. So under your variables section, notice that we have storage name, and on the right hand side we're just using a bunch of functions and assigning it to storage name. So the idea is that when we have to go call them in our resources, it's going to be a lot shorter than if we had to write that whole thing in there. And what's more interesting is that you can nest your variables within a JSON object. So on the left-hand side, you have this variables, environment settings, test, instance sizes, etc. And then on the right-hand side, we have a parameter that we're defined here. And then down below, you can see that we're calling that parameter, and then we're calling variables, environment settings, and then using the square braces to then call within that nested object. I know that seems really confusing, but just take a moment to look at it, and it will make sense. And you'll just understand that there's a lot of power there. So there you go. So last on our list here for ARM templates is outputs, and outputs return values from deployed resources so you can use them pragmatically. This is very simple. So the idea here is that you have outputs, and let's say you want to output the resource ID, so you can say that it's a string, and in the value you could use a variable or a bunch of functions. And the idea is that when you use the CLI, so imagine here you are using the CLI and you're saying, show me this deployment group, and I want to see the outputted value. So see where it says query, says properties output resource ID value. The idea is that now I'm going to be able to pragmatically access it after I've created the resource. And this is a great way of chaining things. So you might have a bunch of ARM templates you want to run in sequence, and you're going to need the outputs to go into the next one, and that is what you're going to use outputs for. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Resource Manager templates, also known as ARM templates. And this helps you deliver infrastructure as code, meaning that when you have a resource such as a virtual machine or a storage account, instead of manually configuring it every single time through the portal, what you can do is provide a configuration file that defines all the properties that you want it to be configured with. And the idea is that you can keep this file and share with other people so they can easily create the same resources as you. And then you know exactly how your stuff is configured. So what we're going to do is launch a new template. Now, you can't go up here and just type in ARM because these ARM templates are managed at different levels. So at one level is a script subscription or the resource groups. So when you have a resource group, you have deployments within them, and that's where these templates are deployed. But just to deploy one from here, what we're going to do is type in deploy. Why they didn't make it so you can type in ARM, I do not know. But if you go down here, we have deploy a custom template. And so from here, we have some common templates. So if I click into web app and I go edit a template, we already have some stuff pre-filled in. I'm just going to go back and discard that, go back to select a template, and we're going to build our own. And by default, we'll have that schema, that content version, which is 1.0.0.0, our parameters, and our resources. So today I want to launch a virtual machine. And what you normally would have to do is go here and look up what is that you want to create. So if it's this Microsoft Compute Virtual Machine, you'd go through here and you'd have to make sure you have all these properties. So you define the resource here, right? The type. And then you define the properties that you want, and down below you can go through here and see them all. That's a lot of work. I don't want to do that, so I'll go to add resource here, drop this down, and click. Where's it? Virtual machine. Where are you? There you are. And I'm going to call this one Wharf, and Wharf and Wharf, because it's not just going to create a virtual machine. It's going to create the other things that I need with it as well, such as the storage account, the network interface, and the virtual network. So you can see that we have a bunch of parameters here. So the name, the type, the name, the admin username, the password, and the OS version. Oh, and you know what? I think I chose a Windows one. I do not want a Windows one. I want a Linux one because that is easier for me to work with here. So we choose Ubuntu. So I'll just fill this in again. All right. And so back up here, we have the Ubuntu version between some versions here. And then there's the type, so that's for replication. Then we have variables here. So if we go to VM size, this is the VM it will set here. Variables are either you can have string values or you can use functions to transform other parameters into other stuff that you'll reference throughout your template. Then down below, we have those resources here. So what we'll do is actually I'm going to copy this because it's very highly likely we're going to want to make some kind of change. And so I have VS Code over here on the left or right hand side. I'm just going to paste that on in there. And what we will do, this is a JSON file, make things a little bit easier here. Great. And what I'll do is just move that off screen, and we'll go ahead and we will save this and we'll see if we can deploy this. So I'm going to type in Wharf here. And we'll launch in Canada East. I'll name this Wharf. We will name the username Wharf, but lowercase, and then we'll do testing 1, 2, 3, 4, 5, 6, capital on the T. Notice that it is hidden there. And then we will choose 14, which is defaulted here, and LRS. We'll go ahead and do review and create. And we'll hit create here. So this is going to fail, I already know, because it has a misconfiguration. It'll tell us how. But while that's going, we'll take a look at our inputs. So this is the values that were inputted. These are the outputs if we had defined any, which we have not. And if we go back to our template, I just wanted to show you that we have that secure string. So when we were typing our password, that's why we didn't see it. So just things like that. So I'll go back up here, and our deploy failed. Why? What happened? So we open it up here. The requested VM size, standard D1, is not available in the current region. So the template we have is not that great. It needs some configuration because we can't use D1. I think that doesn't exist anymore. And so what we really want to use is the standard B1LS. All right, standard B1LS. So I'm going to cut that, and for the time being, I'm going to go back to our original template. And this is one big template. I'm going to look for those variables. Oh, they're all the way at the bottom here. Nice. And so I'm going to just go ahead and paste that in. B1LS, just double check, making sure I spelled that right. Standard B1LS looks good to me. So I'm going to move that off screen. And the question is, what do we do? What do we do when a deploy fails? So let's go take a look at what has happened here. So this all got deployed into a resource group. And under here, this is where our deployments are. So when we look at this template, we can see that it failed. We can click into here, get the same information. And if we click into here, it just brings us back to where we just were. But if we go look at what was actually deployed under our resource group, under the overview, we'll notice that it created the virtual network, the storage account, and the network interface. So when it fails, it creates what it can, but it doesn't roll back, okay? So the question is then how do you do cleanup? So you might think, I'll go to deployments, and what I'll do is go ahead and delete that template, and we can go ahead and do that, which, by the way, you can't edit this template. All you can do is, all we can do here, see, I just want to show you that you cannot edit it. We can download it and stuff like that. But so you might think, well, if I go ahead and delete that template, just making sure we're in the right place here. You might think that might roll back those resources, but it doesn't. It just deletes the template. So if you really want to get rid of this stuff, what you got to do is go ahead and delete all these resources manually. So I wish it kind of had a rollback feature, but that's just how it is. But there are some nice things that Azure does here, which we'll talk about in a moment. So I think we have adjusted it to the correct value now. So hopefully this is going to be all we need to make it work. So what we'll do is go to our deployments here. And we can't do it here, but so we'll go back to the top here and type in deploy. And we'll go to custom template. And what we'll do is build our own template in our editor. And I'm just going to copy the contents here. Okay, we'll go copy. And I will go paste. And we'll make sure that this is all good. Looks fine to me. We'll go ahead and hit save. And we will choose Wharf, so we don't have to make a new one. And we will fill in the name as Wharf. The username is Wharf. I'll call Wharf 2 just in case. Helps us keep track of what we're doing here. Testing 1, 2, 3, 4, 5, 6 with a capital on the T. 14 LRS. And we'll go ahead. Oh, we have one issue here. Cannot deploy resource group Wharf deleting. We'll go back. And we will hit create here. I don't think I deleted the resource group. Let me just go double check. I'm almost certain I deleted all the contents of it, right? Oh, so there's already one here, so we're just waiting for that to delete. Just gonna go delete for us, please. Thank you. It failed to delete. We'll go take a look as to why. Resources not found. We'll go back to our resource groups. Give this a refresh here. Okay, so you know what? I must have deleted the resource group, which is totally fine. I could have sworn I only deleted the contents of it. But we'll just call this Wharf regular then. We'll go ahead and hit create here. And so this time, I have a better feeling about this. And so we'll just have to wait a little bit. It won't take too long. I'll see you back in a moment. Okay, so after waiting a little bit here, our thing seems to be deployed. So if we go to resource groups, we can see that our virtual machine is deployed. So that's pretty much all there is to it. One other thing I'd like to show you is that whatever you have, whatever is in your resource group, you can actually export the template. So if you did configure something manually, all you'd have to do is find the resource, go up here to, it is export template, and there's your template. And it just has that single resource in there. I can't remember if I go into here, if I select multiples, and I go where is it? Export template. Look, it's going to include all that stuff. So if you already have existing resources that you provisioned and you want to have them, that's what you can do. Notice that some things won't be included in the template when you do that, but you can just go ahead and download them, and then you have them for later. So yeah, that's all there really is to ARM, other than learning the nitty-gritties of the actual language. That's just how you work with it there. So what I'm going to do is make my way over to my resource group here, and I'm just going to go ahead and delete this here. And we're all good to go. Hey, this this is Andrew Brown from Exam Pro, and we are looking at Azure Resource Manager templates, also known as ARM templates. So the thing we need to know is infrastructure as code. This is the process of managing and provisioning computer data centers through machine-readable definition files, such as JSON files, rather than physical hardware configuration or interactive configuration tools. IAC comes in two flavors. We got declarative, which is what you define is what you get, and imperative. So you say generally what you want, and it will guess or it'll fill in the blanks for you. For ARM templates, they are JSON files, as we were suggesting above there, that want to provision Azure services you want to configure. They are declarative, so you get exactly what you define. An ARM template is made of the following JSON structure. You should know the structure pretty well because you might see questions where they're showing you that code, so be sure you know all these parts. Schema describes the properties that are available within a template. Content version, the version of the template, you can provide any value for this element. API profile uses value to avoid having to specify API versions for each resource in the template. Parameters, values you can pass along to your template. Variables, things you can transform parameters or resource properties using functions and expressions. And I didn't include in the cheat sheet, but there is a bunch of variations on variables and functions, but I think that's practical skills you should just grab. We don't want this in a cheat sheet. Functions use defined functions available within the template. There are so many functions, it wasn't even worth pulling them out and putting some here. Resources, the Azure resources you want to deploy or update. And under resources, you've got type of resource, API version, the name, the location, other properties, which can be a bunch of different stuff. So there's no consistency there. And then outputs, which are values that are returned after deployment, so you can do things with them pragmatically. So there you go. That is the ARM templates cheat sheet. Hey, this is Andrew Brown from Exam Pro, and we're looking at Azure Container Instances, also known as ACI, and this allows you to package, deploy, and manage cloud applications using containers, or the way I like to think of it as fully managed Docker as a service. Azure Container Instances allow you to launch containers without the need to worry about configuring or managing the underlying virtual machines. And you're going to be able to design isolate containers for simple applications, task automations, and build jobs. Let's talk about some of the reasons why you'd want to use containers over VMs. So containers can be provisioned within seconds, where VMs will take several minutes. Containers are built per second, where VMs are built per hour, so you'll save a lot more money. Containers have granular and custom sizing of vPCUs, memory, and GPUs, where VM sizes are predetermined. So those are the benefits between containers and VMs. ACIs can be utilized for both Windows and Linux containers. You can persist storage with Azure files using ACI containers. And honestly, if you have containers or functions, you have to have an external storage mounted to persist. It's just the way you do it. ACIs are accessed via fully qualified domain names, which is one of the things I really appreciate about Azure services, because most of the services are like that. Azure provides quick start images to help you start launching example apps, but you can also source containers from Azure Container Registry, Docker Hub, and privately hosted container registries. It looks like that, the choice option there. Let's just talk about container groups, because this is pretty much the only major component you have to worry about. These are a collection of containers that get scheduled on the same host, and the containers in a container group share lifecycle, resources, local network, storage volumes. So the idea is that you have these tightly coupled containers, so all of them act as a service within that container group. So here you can see an example of a couple containers that are mounting Azure files on different directories there. And underneath all of that is running on an Azure virtual machine. Container groups are similar to Kubernetes pods. Yeah, and it says similar to, but not really the same thing. Multi-container groups can currently support only Linux containers, which is kind of a bummer, but that's just what it is. And there are two ways to deploy a multi-container group. You can use ARM templates when you need to deploy additional Azure service resources, or just a YAML file when you want to deploy, when your deployment only includes container instances. Let's take a look at container restart policies, and what these do is allow you to change how the policies restart. And there's three different ways. We have always, never, and on failure. So the first one here, always, means always restart the container. And the idea is to keep your container running as long as possible. And the reason why you'd want that is if you're running a web server. Some other providers would call that a service. Then we have never, so run only one time. This is great for background jobs, and so other providers would just call this a task. Then you have on failure, so containers that encounter an error, that's when it should restart. And so it's as simple as just choosing that option. when you are creating that container. Let's take a look at container environment variables, also known as envars, that allow you to pass configuration details to your containers. And you can do this through the portal, the CLI, PowerShell, which that's always the case with Azure. And so it's as simple as just putting in your key and your value. And one other thing I want to point out is that you can also pass in secured environment variables. So the idea is that sometimes you don't want them plain text. So if you have see how I have that Stripe secret key? You don't want anyone ever seeing that in production. So the idea is that and I don't think you can do this through the portal, but you can do this through the CLI or PowerShell, is provide the secure environment variables over the regular one, which is environment variables. And that way you can pass it securely so it's never exposed to human eyes. Let's talk about persisting storage, and we talked about that a little while there when we were looking at Azure files, but containers are stateless by default. So when a container crashes or stops, all state is lost. To persist a state, you need to mount an external volume, and there's quite a few different things we can mount: Azure files, secret volumes, empty directory, cloud git repo. So you got a few options there. And to mount a file volume, you need to do this via PowerShell or CLI, and you're going to give the following details. So when you launch the container, there's going to be nothing in the portal, so you got to do it this way. All right. Let's talk about some of the CLI options that we can use to troubleshoot our containers. A lot of this stuff is probably accessible via the portal, but it's great to know how to do this via the CLI. So the first thing is getting the logs. So you can use AZ container logs, and that's going to bring you the logs back. Then you can use AZ container attach. And this is going to give you diagnostic information about when the container is starting up, probably with a cloud init information. Then you have AZ container exec, and this allows you to execute remote commands. But what you can do is use bin sh, which actually will allow you to have an interactive container. So it's like having the terminal right to the container, which is very, very, very useful. And the last is just grabbing metrics from Azure Monitor. So AZ Monitor metrics list. You could use the portal for that, but I just wanted to show you all those things because they might show up on the exam. Hey, this is Andrew Brown from Exam Pro, and we're going to take a look at Azure Container Instances. So here it is. So all we got to do is go to Container Instances. We'll hit Add. And the nice thing is that Azure provides us with a Hello World one, so it's very easy for us to get started. It's a Linux machine, and it looks like it's pretty inexpensive there, so we'll stick with that. I'm going to create a new group here. We're going to call it Banana, and we'll name the container instance Banana. And East US 2 seems fine to me. You'll notice we're on a quick start image. If we wanted, we could use something from the Docker Hub and provide our own link, but we'll just stick with the quick start image for today. We're going to go ahead and hit next to networking just to see what we have as options. You can make it public or private. We'll go to advanced. Hold on here. Yep, those are just the ports you can expose. We'll go to advanced, and for the restart policy, we can set on failure, always, or never. We can pass in environment variables, and I've covered this a lot more in detail in the lecture content, so we don't need to really dive deep into this. And we'll go ahead and create this instance. And so we'll have to wait a little while here, and I'll see you back in a moment. Okay, and so after a short wait, our container instance is ready. We'll go to that resource there and take a look around. So on the left-hand side, we can go to our containers, and there we can see it running. We can see the events down below of what's going on. So you can see that it's pulled the image, it successfully pulled it, and then it started the container. Some properties, nothing interesting there. The logs if we wanted to see stuff. And if we wanted to connect to the instance, we could also go here and hit connect, which is kind of nice. I don't have any purpose to do that right now. And it's also not going to work the way we're doing it, but I just wanted to show you, you had those opportunities. You can do identity, so that means manage it with role-based access controls. But what I want to see is actually this hello world working. I'm assuming that must be a hello page. I've never looked at it before. So we're going to go here, grab the public IP address, and paste it on in the top. And there we go. So we have deployed a instance onto Azure Container Instances, or a container, I should say. So nothing super exciting to talk about here, but we do need to know the basics there. If we wanted to deploy other containers, it's just the one there, so that's all you really need to do. But yeah, So yeah, hopefully that gives you an idea there. I'll just go back to the list here so we can see it, and we'll go ahead and just delete that. Probably do it via the resources on the left-hand side, like I always like to do. And we will go into banana here, and we will delete banana, and there you go. Hey, this is Andrew Brown from Exam Pro, and we were looking at Azure Container Images cheat sheet, and this is a 2-pager, so let's jump into it. So ACI allows you to launch containers without the need to worry about configuring or managing the underlying virtual machine. ACI is designed for isolate containers for simple applications, task automation, build jobs. Containers can be provisioned within seconds, where the VMs can take several minutes. Containers are built per second, where VMs are built per hour, so you get greater savings when you're using containers. Containers have granular and custom sizing VPC memory and GPU. When VM sizes are predetermined, ACI can deploy both on Windows and Linux. You can persist storage with Azure files. ACIs are accessed via fully qualified domains, so it's just like a domain name. Then we have container groups. These are a collection of containers that get scheduled on the same host machine. The container is a container group share. So you got lifecycle resources, local network storage volumes. Container groups are similar to Kubernetes pods. Multi-container groups currently support only Linux containers. This is one of the cases where it's not Windows, it's Linux, okay? There are 2 ways to deploy multi-container groups. You have that via an ARM template and YAML file. I imagine you can do them via blueprints as well. A container restart policy specifies what a container should do when their process has been completed. ACI has 3 restart policies: always, never, and on failure, okay? We'll go on to the second one here. So Azure containers are stateless by default. When a container crashes or stops, all state is lost. To persist state, you need to mount an external volume. You can mount the following external volumes, so either Azure Files, Secret Volume, Empty Directory, or Cloud Git repo. For container troubleshooting, these are just Azure CLI commands you should really know. So I'm just going to list them out here. You got AZ container logs, AC container attach, AZ container exec, which is for execute, and AZ monitor metrics list. So there you go. That is the ACI images cheat sheet. Hey, this is Andrew Brown from Exam Pro, and we were looking at Azure Container Registry, also known as ACR, which create and maintain Azure Container Registries to store and manage your private Docker container images and related artifacts. So Azure Container Registry is a managed private Docker registry service based on the open source Docker Registry 2.0. And the idea here is that you can use container registries with your existing container development deployment pipelines. And it also has this thing called registry tasks to build container images in Azure. And the idea here is that you can pull images from your container registry to various deployment targets like Kubernetes, DCOS, which I forget what it stands for, but it's basically an operating system for containers, Docker Swarm, and there's also many Azure services that directly support ACR, so AKS, Azure App Service, Azure Batch, Azure Service Fabric, and a lot more. So it's just a matter of saying, hey, use this from ACR, and it works right away. Developers can also push to container registry as part of a container development workflow with delivery tools such as Azure Pipelines and Jenkins, and it's so easy to push to container registry. There are many ways to work with ACR via the CLI, the Azure PowerShell, Azure Portal, Azure SDK, and there's also this really good extension called Docker extension for Visual Studio Code, something you absolutely want to install, and maybe I'll make a full slide on it because I like it so much. Let's take a look here at ACR tasks, which allow you to automate OS and framework patching for your Docker containers. And we have a few different options here. So the first is quick tasks. These allow you to push a single container image to a container registry on demand, and you don't need to be running a local Docker engine installation to do it. So that's a really good benefit. You can also trigger some automated build actions. So maybe you push some source code updates, you update the container base image, you want to do it on a timer that's on a schedule. You can also have multi-step tasks. So you have to go through the various steps to complete that task. For each ACR task, it has an associated source code context. This is the location of the set source files used to build a container image or other artifact. Tasks can take advantage of run variables, so reuse task definitions and standardized tags for images and artifacts. So there you go. Hey, this is Andrew Brown from Exam Pro, and this fall long we are going to be working with ACR, or also known as container registries. So type in ACR at the top. Actually, if that doesn't work, type in container, and we will go to the registries, and we'll create ourselves a new registry. And that allows us to have multiple container repositories or images hosted here on Azure. So I'm going to just type in my ACR, and we'll say OK. And the registry name is going to be my ACR. I'm just going to put a bunch of numbers here, so maybe 8080, 81. It probably doesn't like the hyphens. There we go. All the names are crazy. You just have to flip around to figure it out. We're going to choose basic because we can do everything we want on basic. We'll go ahead and hit review and create. And we'll give it a moment to allow it to start deploying. And we'll just wait till this is done deploying our registry. All right, so that took less than 5 seconds, and we'll go ahead and go to that resource. And so what we need to do is go to access keys. We're going to enable admin users so that we can actually log in via Docker to our image. So now what we need to do is get some repositories going. And if we go over to repositories tab, I don't think there's much we can do here. I don't know if we can create repositories directly here. I always just push. Yeah, so you don't have a button to say create a repository like GitHub. You actually have to push to it. So I'm going to go to GitHub and I'm going to create myself a new repository. I'm going to call, under Exam Pro, we'll say my ACR. It's already there, so I'll say new. And we'll go down below. Actually, it doesn't matter. We'll just go ahead and hit create. And from there, I'm going to open this up in Gitpod. All you have to do to open something up in Gitpod is to attach this end here. You can also do this in your local environment, but you do have to have Docker set up. And so that's why it's easier to use Gitpod. Now, Cloud Shell in Azure actually has Docker installed, but it doesn't run a Docker instance, so it's not that easy to work with. So it really is easier to just work with Gitpod here or locally if you have Docker installed. So we're going to say Docker login, and then we're going to provide the login server. We'll hit enter. It's going to ask for our username, so that is our username there. So I'm going to paste it in. It's going to ask for our password, so I'm going to copy that, paste that on in there, hit enter. And so now we can push to that repository. I'm going to pull a image called Hello World. That's just a standard application to say Hello World. If we do like Docker run itd Hello World, I think that's what it is to type it. Whoops, I gotta actually spell it right. Then we could probably run it. Over here, there's like a Docker tab so we can see if it's running. Notice that it exited. If we view the logs, probably just says Hello World. Yeah, hello from Docker. So there you go. That's a simple way of running a Docker container. And terminal will be used for other tasks. Press any key to close it. So I just hit space there. ITDD, or T I think is for the tag name. So it's called Hello World. So we type Docker images. It shows up there. I is for, I don't know, interactive. D is for daemon, so it runs in the background. But anyway, we want to push this to Azure. So the way we're going to do that is we're going to type in Docker tag, because we have to tag this image. And we're going to choose the image ID here. And then we need to provide the repository name. So I'm going to assume it's the login server. And then we just say example, hello world, hit enter. And then we can say Docker push and then copy this here. And that should push it over to Azure. We'll go back over here, give it a refresh. So our repository is there. So that's all it takes to push. So this is one part, but we'll figure the other part next here soon, okay? Hey, this is Andrew Brown from Exam Pro, and what we're going to do is use the last follow along in order to reference an image in our container here, because we pushed an image, but what if we want to reference one as an application in an actual Docker file, because that is a very common use case. So in our Gitpod environment, which we still have, I'm going to type in Docker file. And in here, what we can do is reference our image. I always forget what the top line is, export, run, import something. So I'm going to just look for an example. I'm going to go to Docker Ruby, because I know how to use this image pretty good. So we'll just go with it. And it's from. I always forget that. So we'll type in from. And the idea is that we want to reference something like this. But I know if we use the Hello World one, it's a bit finicky to build. So I don't want to use this one. But I'm going to just say Ruby or Yeah, Ruby's fine here. And so we're gonna have to pull the Ruby image. So we'll say docker pull Ruby. And we'll have to push this one. So we'll pull it. Give it a moment. And now we'll type in docker images, and we need to grab the Ruby image ID, and we'll say docker tag this one, and we got to go up and grab this part here, paste that in. I could just say Ruby here, and then we can do docker push Ruby. And while that's going, I'm just going to go here and type in run echo hello Ruby, because the idea is we just want to build a Docker image that's from a remote location. So what I'm going to do is just save this. So we'll say save my Docker file. It's the only file we saved here. Just waiting for that to finish pushing. And then what we're going to do is we're going to, close this environment and then launch it again, because I don't want to have any of those images there. I don't want to have to figure out how to delete them. It's like docker RMI. It can be really finicky about deleting images, but the idea is I just want to make sure they're not there so that when we pull, we know that it actually is pulling from there, not locally. We will have to do a Docker login here in a moment. So we'll type in docker login, and we'll go back over here and we will log in. Say allow. We'll go back to here. We'll grab the username. We'll go back over to here. We'll grab the password. So that's good. And hey, where's our Docker file? Our Docker file seems to be gone. I guess we forgot to sync it. And that's totally fine. We'll just type it in again. It's not a big deal. From here, we'll say Ruby, and I'll say run echo hello Ruby. And so now what I want to do is I want to do docker build period. And so if we are logged in, we can pull it, so it's in great shape. So it's the fact that we are pulling that image, and that was the other part I wanted to show you there. So it doesn't matter if this finishes because it obviously is working, but we'll give it a second here to finish downloading. There we go. And so that's all. So we'll go ahead and close this, and we'll make our way back over to Azure, and we will go and type in resource groups. And we will choose MyACR, and we'll go delete resource group. And we'll delete that. And we're done. So there you go. Hey, this is Andrew Brown from Exam Pro, and we're taking a look here at Azure Container Registries cheat sheet. So ACR is a managed private Docker registry service based on the open source Docker Registry 2.0. It uses Azure Container Registries with your existing container development development and deployment pipelines. Use ACR tasks to build containers images in Azure. Pull images from an Azure Container Registry to various targets. And targets could be Kubernetes, DCOS, which is I can't remember the name of the full name of that operating system. Docker Swarm. For ACR tasks, this allows you to automate OS and framework patching for your Docker containers. You can trigger them. You can trigger automated builds by source code, updates to container-based images, triggers on a schedule. You can create multi-step tasks. Each ACR task has an associated code context, and tasks can take advantage of run variables. That's the end of it. There you go. See you in the next section. Hey, this is Andrew Brown from Exam Pro, and we're looking at Azure App Services, which allows you to quickly deploy and manage web apps on Azure without worrying about the underlying infrastructure. And specifically, this is known as a platform as a service. So Azure App Service is an HTTP-based service for hosting web applications, REST APIs, and mobile backends. And you can choose your programming language, and it can either be Windows or Linux environment. And it's a platform as a service. So if you've ever used Heroku, it is basically the Heroku of Azure. And so Azure App Service takes care of a lot of the underlying infrastructure for you. So it can do security patches of the OS and languages, load balancing, auto scaling, automated manager. And then there's a lot of things that you can implement. And so for integrations such as Azure DevOps, GitHub integrations, Docker Hub, package management, easy to set up staging environments, custom domains, attaching SSL certificates. So you can see that it just basically takes care of everything for you if it's really hard for you or time consuming for you to do all this on your own in Azure. And the way it works is you pay based on an Azure App Service plan. Honestly, I find these really confusing. I really like how AWS does Elastic Beanstalk because you're just paying for the underlying services. But Azure has all these crazy tiers here. But you have shared tier, which is free and shared, doesn't support Linux. You have the dedicated tier, which is basic, standard, premium version 2 and 3, and the isolated tier. And so another thing I need to note is that Azure App Services is not just for traditional VMs for monoliths. You can also run Docker single or multi-containers. And when you set up a project, you're going to choose your domain name on the azurewebsites.net. Obviously, you can override that with your custom domain name, but there you go. Let's talk about Azure App Services runtimes. And so let's define what a runtime is. A runtime is software instructions that are executed while your program is running. And so runtime generally means what programming language, libraries, and frameworks you're going to be using. And so runtimes for Azure App Services are predefined containers that has your programming languages and probably some commonly used libraries for those languages installed, and probably commonly used languages for web frameworks. And so the idea is that you're going to choose your runtime. It could be .NET, .NET Core, Java, Ruby,